Hello there, welcome to your very first tutorial on getting started with C. Now in this tutorial what we are going to do is we will be discussing the very basic fundamentals of programming in general, because if you are going to learn any programming language it is essential that you know the basics of programming. So that is what we are going to do in this one, and I'll also try to answer a few basic stupid questions like what is programming, and I'll tell you a bit about the various programming styles used by programmers all over the world. So enough of me talking, then let's get started with introduction to programming. The very first question which comes up when we are talking about programming is what does programming actually mean? Now if you go and Google it up, what you guys will get is that a programmer is an organism that turns caffeine and pizza into software. Well, now I do agree that this definition is indeed quite neat, but hey, let's have a look at a more formal one. Programming is basically the process of giving instructions to the computer or machine in the form that it understands, right? So as we all know, machines are made up of switches, and switches have only two states: either the switch is on or the switch is off, right? So that is how the data is represented in the memory, and that is how it all started. It all began with the advent of Boolean algebra, the language of zeros and ones. Now what happens is that all the alphabets, all the numbers and all the special symbols have been assigned a unique sequence of zeros and ones, and that is how they are represented in the memory. What this means is that a computer does not look at A as an A, it looks at A as a collection of zeros and ones, right? And that is how it deals with it. So earlier we had these huge multi-story, I don't think even we should call them computers, but we had these huge multi-story buildings which could perform only simple arithmetic operations like addition, subtraction, and even for doing that they took hours, right? So next these boxes started popping up. Now they did look a bit neat, but again the programming capabilities were very limited. And where have we reached today? We have all-in-ones, we have smartphones, which basically consist of a single chip, and we can do anything that we can think of. We can contact anyone anywhere in the world, we can track anything, we can book movies sitting at home. So the possibilities are simply endless. So how did all this happen? Again, there are two parts to it. The first is the hardware aspect and the second one is the software part. In this series we'll be dealing with the software aspect. So again, now I'll be telling you guys about the history of programming, how we began and where we are currently. So when it comes to programming, we need to talk about two fundamental things. The first one is the programming paradigms and the second are the programming languages. So let's get started with programming paradigms. Now what is a paradigm? A paradigm is basically a method used for doing anything, right? So programming paradigms are basically techniques which are used by programmers all over the world for different applications. There are different techniques which are suitable for different applications, and we sometimes even use a hybrid of them for getting the most out of a code. So the very first programming paradigm is the monolithic programming style, which was used in early languages like Logo and Basic. Basically in these languages we could only write code step by step, right? We could not do anything else with it. Next came the structured programming, which basically added more control over the data. In monolithic programming, what happened was that the entire data was treated as global and anyone from outside could actually come and edit the data. So in structured programming approach, that was taken care of and the data was made local to the code. But again, in the case of structured programming, there was no user control over the data. In the case of object-oriented programming, again required securities were added to prevent hacking of data. And the latest and the currently trending one is the component-oriented programming language or the component-oriented programming style, which is basically an enhancement of the object-oriented version. And there is only one language in the world at the moment which supports component oriented programming, which is C#, which is used for making all the iOS applications. Let's talk a bit about the different programming approaches while we are discussing paradigms. So the very first approach is the linear or sequential approach, which was used in the monolithic programming. And what happened was that entire code was executed line by line, one after another. There were no decision making capabilities and we could not do much with our code. Next is the method based approach, which was again in the structured approach or the structured style. What happened in this approach was that the entire program was divided into different modules and these modules work together for getting the job done. The structured approach is also similar with a bit enhancements in the data handling capabilities. Next is the class-based approach, which was adopted in the object-oriented style. And in this, what happens is that the data and the associated functions are integrated into one unit called class, which is then used for further applications, right? Next up is the scripting style. Now scripting style is basically based on the client server model and is used exclusively in the web development. So what happens is that the client requests the server to do something and the server gets the job done. That is how the scripting style works. And the currently trending one are the tools or apps, right? So any games that you play on your phone or any softwares which you use on your computer basically come under this category. Now the most important thing about tools or apps is that they are designed for one specific purpose, right? So let's say if we are editing a photo in say Photoshop and we want to edit a video, we cannot do it in the same software. We need the another software for doing another task, right? Again, if you are playing Angry Birds, you cannot play Temple Run in the same game. You need two different apps for two things, right? So that was it about the tools. Now let's talk about the second essential thing, which are the programming languages. What is a programming language? A programming language is basically the way in which we interact with the computer, right? It is how we give instructions to the computer for getting our job done. Just like you and me are talking in English at the moment, similarly we need something to talk with the computer, right? And that is where programming languages come in handy. So programming languages are again classified into two types. The first one are the low level or machine level languages like Logo and Basic, and the next is the high level languages like C++, Java, C Sharp, etc. Now what is the difference between the two? The low level or the machine level languages are meant to be more friendly on the hardware side, right? On the other hand, the high level languages are meant to be more user friendly. So where is C? Right, so C is considered a middle level language. And why is that? Because when Dennis Ritchie, the man who developed C, was writing it, he wanted C to be somewhere in between these two extremes, right? He wanted C to be equally good with the hardware and equally interactive with the user. So that is why C was made in such a way that it bridges the gap between these two things, and C is the only language in the world which is considered a middle level language. So I guess that is enough about the fundamentals which you guys need to know at the moment. I welcome you all to the world of programming, and from the next tutorial what we will be doing is we will be downloading and installing the required software. Don't worry, it is absolutely free, and we'll get started with programming in C. Right, so thank you guys for watching. I'll see you guys in the next one. Okay, so welcome back to another tutorial. Now in this tutorial what we'll be doing is we'll be quickly downloading and installing the required software and setting up the environment. So what you guys need to do is just go to this link right here, hit the download button, and the download should begin automatically. I have my downloaded file right here, so I'll quickly guide you through the installation process. Okay, so once we are done unpacking, we get to select the language. Just hit English obviously, and I agree. Next, and install. The installation is pretty simple. I know you guys can do it, but still, just for the sake of formality, I thought I'll just guide you through it once. Also, once we have installed the software, I'll quickly tell you a bit about the interface so that you're good to go. Now by the time we are done installing, I might as well tell you guys this, that this software runs on all the versions of Windows but not on the Mac, right? If you want, or if you're using a Mac right now, you can write C programs directly in the terminal using the VI editor or any other editor which is available in your software, right? So once we are done, let's select run dev C++ and click finish. We need to set up a few things during the first time. So again, you can choose your language if you want to change anything, but since we are talking English, I guess we'll be going ahead with English only. Click next. You can choose whichever font you like. I like all the default ones, so I'll be leaving everything as it is. And in this page, make sure you do not do any change, right? Just let whatever it be, because if you click this button, as it says, you need to be very patient, and trust me, it takes a lot of time, and we do not need all these extra additional header files at the moment, right? So just go ahead and leave everything as it is and click next. Okay, so once the setup has completed, just click on OK, and now it should hopefully open up the software, right? Okay, so there we go. This is what the interface looks like. Now I'll quickly guide you through it once so that you don't feel overwhelmed at the moment. We only use two of these options. To be very honest, we don't use 90% of these stuff here. The very first option which we use a lot is the file option, because whenever we create a new file or save our project, and the next option which we use here is the execute option, which is used to run our code, right? And we don't really use all the other features, but still I'll tell you what they are. Edit obviously contains all the cut, copy, etc., and search is used to find and replace some text in your files. View is used to change the interface if you want to, but I would recommend sticking to the default one at the moment. A project is when we are working with multiple files. Execute, as I said, is used to compile and run up code. Tools basically contain all the additional options available. You can go ahead and you can change the fonts, etc., if you wish to, and you don't need to worry about these three things. So yeah, again, that is how the interface looks like. So go ahead, install it, and I promise we'll start coding from the next one. Welcome to another tutorial. Now, as promised, from this tutorial we'll be starting to write some code. So before we can write anything, we need to create a new file. There are two ways of doing that. Either you can go to file, new, and click source file, or you can go to this button right here and click source file. So the very first thing which we need is we need to save our file as a .c file. So let's go ahead and save it. Go to file, save as. Wherever you want to save it, I'll just name my file hello, and just make sure that you save it with a .c extension, right? So there we go. And now as we can see, the file has been saved with the name hello.c. Okay, so let's start writing something, right? Now what happens is that whenever we are trying to learn a new programming language, it is basically a tradition that the very first piece of code which we write is used to display the text hello world on the screen. So that is what we are going to do in this one. Now before actually writing hello world, we need to include a few files for our thing to work, right? So these files are basically called header files. As you can see, they have a .h extension. Now what is a header file? A header file basically contains some pre-written functions for us to use, right? Since in this case we want to display some text on the screen, so we need to interact with the monitor, right? So we did not write code for doing that. That code has already been written for us already, so we just need to use it. So for using that code, or this is basically the file where that code is written. stdio stands for standard input output, and .h again is the .header extension. Now hash here basically means preprocessor, which means that all the statements or all the instructions following hash are executed before everything else in the code. And include is a keyword which we'll be talking about in the next one. So the next and the most important part of a program is the main function. Now main function is basically the driver function of a program. Whenever we run our code, the control first passes to the main function, and we can redirect the control to anywhere else from within the main function. So this basically means that if you do not have a main function, your program will not run. So make sure that whenever you're writing a program, you have a main function in there. Now we wanted to print hello world on the screen. So the function used for printing anything is the printf function, and every statement in C ends with a semicolon. Right, so this is the general syntax of the printf function, and whatever text we put here between these two quotes is what is displayed on the screen. So we wanted to display hello world, so let's go ahead and type hello world in there. It's a smiley, of course. So now what this statement will do is it will simply print hello world on the screen. So let's run it and see if it runs properly or not. Alright, so there we go. We get a sweet decent hello world output on the screen, and this is basically the simplest program which one can write in C. So go ahead, try it out, make sure you write your name and everything else which you wish to on the screen, and I'll see you guys in the next one. Okay, so welcome back to next tutorial. Now in the previous one we made the hello world application, if you guys remember. So I guess you are all familiar with whatever is written here so far. And in this tutorial we'll be talking about something called as character set, keywords and identifiers. So let's get started with character sets. Now a character set is basically a collection of all the symbols, alphabets, numbers, everything that a language recognizes, right? So in case of C, all the numbers from 0 to 9, all the characters from A to Z, both small and capital, and all the special symbols which we use mostly, the curly braces, the angle brackets as well as the square brackets are all supported. Apart from these, C also supports the enter and the backspace keys, which are represented by special characters which we'll be talking about in the next one. Right, so that was it about the character sets. Let's move on to keywords. Now keywords are actually some special words which have a certain special meaning for the compiler, right? Which basically means that their grammar has already been defined. If we use such a word, the compiler knows what to do with it. So let's say I write int here. Now int is a keyword, so as you can see it is highlighted or it is bolded, right? Let's say I write anything else, so you can see the difference. The keyword has been bolded but this has not been bolded, right? So all the keywords in case of Dev C++ appear bolded. So a keyword is basically something which has a special meaning for the compiler. Whenever a compiler sees that particular thing, he knows what to do, right? Or rather it knows what to do, whatever. So that is what a keyword means. You will understand what I mean in the next tutorial. Here I am just telling you the theoretical concept, so when we'll actually use them in a code, it will be very easy to recognize. And the next thing which we want to talk about right now is identifiers. Now keywords are something which are already defined. On the other hand, we the users or the programmers need to define certain special words for our easy reference, right? So those things are called identifiers. Now again, int here stands for integer basically. So I'll give a name to integer, say marks. So marks is something for my reference. It has nothing to do with the compiler. So that is why marks is called an identifier, and int here is a keyword, right? So that is what keywords and identifiers mean. Now since we guys have time, before ending this tutorial I'll quickly tell you guys about constants and variables. Now constants and variables are basically both named memory locations, right? Since our program deals with data, we need to store some content and we need to modify it as and when required. So we need some special variables or constants for storing the data and manipulating it. So again, if I make one integer here and I say marks, now this is the exact same statement which I wrote just a while ago. So marks here is basically an identifier, and marks with some value is basically a variable, right? So marks individually refers to an identifier, but when we assign a value to it, it basically becomes a variable which is an address in the memory somewhere which has the value of 1, right? So this is a variable because its value can be modified any number of times. If I go here and write marks is equal to 25, the new modified value of marks will become 25. But on the other hand, if I go ahead and I write something called as const here, so as you can see const also got bolded here. So it basically means that const is again a keyword. Now the const keyword is used for declaring constants. So what this means is that marks is now a constant, so we cannot modify the value here. So if I go ahead and I say marks equal to 25, this statement is now invalid. When you try to run it, as we'll see in the next one, the compiler will show an error. It will say that you are trying to modify a constant, which is not possible, right? So once again, character sets are all the numbers, letters, symbols which a language recognizes. Keywords are the special words which carry a special meaning. Identifiers are names given by users or programmers for their easy reference. variables and constants are named memory spaces. Variables can be modified whereas constants cannot, right? So that was all about keywords, identifiers, and constants and variables for this tutorial. So I hope you understood everything, and I'll see you guys in the next one. Alright, so welcome back to the third one. Now in this tutorial we'll be talking about something called as data type, right? So what happens is that we need to store data, right? So before storing data we need to create some memory space for doing so. The memory space will actually be the location where we'll store that data, right? So everything related to data is taken care of using these data types. Data types, if you go by the theoretical definition, are the way to organize and handle data, right? So there are three types of data types in C. One is the basic or primitive data types. Next is the user defined data types, and the third category is something called as a derived data type. So in this we'll be talking about the basic ones, and we'll deal with the other two in the later tutorials. So C actually gives us 5 basic data types, which are int, char, float, double, and void, right? So these are the 5 basic primitive data types provided by C. Int stands for integer, char stands for character, float is a floating point or a decimal number, double stands for double precision floating, which again is a decimal number. Now there is a slight difference between float and double. Float is used for all the normal decimal values. On the other hand, double deals with values like the size of the galaxy or the size of an atom. You know, the numbers which are very huge or very small, those are represented using double. And void, if you go by the literal meaning, stands for nothing. So similarly in C you cannot actually declare any variables of type void. You can declare variables or constants of all these 4 types. Void is used exclusively in case of functions. Okay, so now let me just quickly give you an example of one of the type. So let's say we are dealing with int here. So int is for integers. Okay, before I do that, let me just quickly tell you the different memory sizes which these occupy. Int takes 2 bytes or 4 bytes of memory depending whether your system is 32 or 64 bit. Char takes 1 byte of memory, float takes 4 bytes, double take 8 bytes, and we cannot declare anything of type void, so it does not occupy any memory, right? So we are talking about integer. So let's say I again say marks is the name of my integer type variable. So let's quickly assign some value to marks. So if I say marks is equal to 10, this is something called as initialization or assignment statement. So this means that there is a memory location somewhere in our RAM with the name marks and the value of 10. So that is what this statement basically means, and that is how we use data types. We use data types to make different sorts of variables and handle data appropriately. So that is all about data types for now. So thank you guys for watching. I'll see you guys in the next one. Okay, so welcome back to another tutorial. Now in this tutorial we'll actually be dealing with how to read inputs from the user. We saw how to display some text in the hello world program, right? But we did not see how we can take inputs and store it in the memory. So that's what we'll be looking at in this one. So the very first thing which we need for taking input is obviously a memory location. So that is what we did with this statement here. We reserved 2 bytes of memory with the name age. So now let's ask the user to enter the age. So we'll just simply display the message enter the age, and for reading the values we use a scanf statement, which is actually used along with printf, right? Printf and scanf are the most widely used statements in C. This is the basic syntax of a scanf statement. Scanf, and which is exactly the same as the printf. There is only one difference, which is that inside these double quotes we use something called as a format string, which tells the compiler what type of variable we are dealing with, right? What is the data type that we are dealing with, and we need to use ampersand here, which stands for address of. So what this statement basically means is read an integer variable which is specified by the %d, store it in the address of variable age, right? So that is what this statement actually does. Now if we are going to read a character, we'll use %c here, and if we are going to read a floating point number, we'll use %f here. but since we are dealing with integer in this case, we'll use %d. So now we have taken the input from the user, so let's go ahead and display it back to the user so that we can check if the code is running properly or not. So we'll simply say you entered, and again we'll use %d, and I'll say age. Note that here we do not need to use the ampersand operator because we do not want to refer to the address anymore. The variable name is enough for the printf statements. So let's actually run this code and see what we get, and then I'll tell you the flow. Right, so it is asking me to enter the age. My age is 18, so I'll go ahead and enter 18, and it will say you entered 18. Perfect. So that is what the printf and scanf statements are used to do. Now you might be wondering how this value 18 came here, right? So what happens is that the %d is replaced by the next integer following the comma, right? So in this case %d is followed by the name age, which is an integer, right? So that is why the value of %d is replaced with the value of age. So basically age is substituted here, and similarly here also the %d refers to an integer address, right? So the address of age is used for storing this value, and again the value of age is used to display here in case of %d. So that's how the printf statement actually works for the data types. Alright then, so that was how you read and display content. So go ahead, make a simple program asking the user for their age, marks, etc., and you can display it back. So keep practicing, and I'll see you guys in the next one. Okay, so what we are going to do in this tutorial is that I'll be telling you guys about a few miscellaneous things like comments and then escape sequences. So without further ado, let's get started. Now comments basically are used for hiding a piece of code or writing some information for yourself. Let's say I am writing two numbers here, so I'll make two numbers, say marks 1 and marks 2. Now just for my reference, I need to mention somewhere that the marks 1 refers to this particular subject and marks 2 refers to some other particular subject. So I cannot write it here as it is, because then the compiler will show an error, right? So that is where the concept of comments comes in. Now comments basically are of two types in C. Either we can have single line comments or we can have multi-line comments. Now single line comments are given by this double slash. So as you can see, it turns sort of sky blue color, and then we can write anything, say marks 1 is equal to maths, and again we can go and we can write marks 2 is say English, right? Now what happens with comments is that this particular piece of code will not be seen as a piece of code by the compiler. Basically it will ignore whatever is written after these two slashes, right? So that is what is a single line comment. Now let's go ahead and write the same thing using something called as a multi-line comment. Now multi-line comment is basically given by a slash followed by a star, and it goes on till another star and slash, right? So this is basically now a multi-line comment. As you can see, the color is still the same, but we have used only these four character or symbols here, right? So we can also write anything else that we want to, like name or who made this and date and stuff like that. Now this is not the most common use of comments. Comments are used for another very important task which you will guys understand in a few tutorials, right? So that was all about the comments. Now coming to escape sequences. Escape sequences are basically a bunch of characters followed by a backslash. So we will have backslash and a backslash n, etc. There are some 7 to 8 escape sequences available, but the mostly used ones are the n and the t, right? So let's quickly make use of them so that you understand what they actually do. So here let's say my name is, right, and we'll say what I like coding. Alright, so this is my statement. I just want to print it, so let's see if we are getting the output or not. So there we go, we got the output. Now I want this text I like coding in the next line, right? I do not want it in a continuous on a single line, so I want this on another line. So we use the backslash n for that particular task, it basically moves the cursor to the next line. So now that we have inserted backslash n, now if we go ahead and check the code again, as you can see, it is moved to the next line. So that is exactly what I wanted to do, right? So that is what the backslash n is used for. And if we go ahead and we make use of backslash t now, again let's check out the output. So as you can see, there is a tab space between the two lines. So that is what the T is used for. It basically stands for a tab, which is equivalent to 6 spaces, right? So that is what the backslash n and the backslash T do. They basically help us to make the output a bit pretty, right? So that's all I have for you guys in this one. Thank you guys for watching, and I'll see you guys in the next one. Alright, so welcome back to the last tutorial for this section. Now, till now we saw how to read inputs from the user and display them back, but we did not actually see how we can modify some data, right? So in this tutorial we'll be dealing with that. We'll be looking at how we can perform some arithmetic operations on simple integer data. So for performing any operations, we use something called as operators, right? In maths also we have the addition, subtraction, multiplication, division, etc., and we have all those in C along with a bunch of other operators. But I'll quickly tell you guys the mostly used operators. We have something called as a unary operator. Now the most commonly used unary operator are the plus plus and the minus minus operators. Plus plus is called the increment and minus minus is called the decrement operator, which basically is equivalent to adding 1 and subtracting 1 from any value, right? Next we have something called as binary operator, which contains all the mathematical operations used: addition, subtraction, multiplication, division, and the percentage or modulus operator. Now what this does is it basically gives us the remainder. Whenever we use the division operator, we get the quotient, and when we use the percentage or modulo operator, we get the remainder, right? And there is something else called as a ternary operator, which we'll be taking a look in the next tutorial. So let's quickly read two numbers and try performing any one operation. So I'll say num1 and num2. Let's keep it simple. So I'll be quickly reading two values. I'll ask the user to enter two values, enter two numbers, and I'll scan two numbers. So for scanning two numbers, you need not use two different lines. You can add two %d here and you can read all of them in a single line. So I'll say num1 comma ampersand num2. Don't forget the ampersand, it is very important. And now I'll simply display the sum is, the sum is, and I'll say %d, and I'll perform the addition here. I'll say num1 plus num2, right? So this is the simplest operation which we can perform on any numbers. So let's actually run the code and see what we get. Enter two numbers, 4 and 5. The sum of 4 and 5 is 9 exactly. So it is working just fine. So that is how we deal with operators in C. So you can go ahead and try all the other operators which I told you guys about. Try out the plus plus and minus minus operators and the other operators, other mathematical operators as well. And we'll be talking about ternary operators in the next one. See you there. Okay, so now that we are in section 3, we'll be taking a look at different ways for controlling the code, right? This section is going to be all about how to make decisions, how to repeat some statements and stuff like that. So in the last tutorial of the previous section, we talked about operators, right? We dealt with unary and binary operators there, and I said I'll be telling you guys about the ternary operator here. So this is what that tutorial is going to be about. It is going to be about the ternary operator, which basically helps us in making decisions. Now it is not used very frequently because it is very complicated, but again something like this exists, so I might as well tell you guys about it. So a ternary operator basically has this syntax: a question mark followed by a colon and ending with a semicolon. This is what a ternary operator looks at its minimal, right? Now what happens is that we need to enter a condition here before the question mark. We need to enter what we want to do if the condition is true between the question mark and the colon, and we need to enter what the condition or what statements we want to execute if the condition is false between the colon and the semicolon, right? So let's actually make something so that you guys understand. So what we'll be doing is we'll be checking if the number entered is less than 18 or not. Let's make a simple code for doing that. So we need one thing to store it, so I'll say int num, right? So if the number is less than 18, we'll say the number is less than 18, and if the number is not less than 18, we'll say the number is greater than 18, right? So we have a number and we need to read the number from the user, so we'll say enter a number, and we'll be using scanf to read the value %d ampersand number semicolon. And now we want to check whether this number is less than 18 or not, so we'll enter the condition here in a bracket. So num is less than 18, that is our condition. Now as I said, if the condition is true, what do we want to do? We want to say that the number is less than 18, and if the condition is false, that is if the number is not less than 18, we want to say that the number is not less than 18. So that is what we'll be entering here between the colon and the semicolon. We'll say the number is not less than 18. Okay, now where's the semicolon? There we go. And this is what a ternary operator looks like at its maximum form. The question mark, again the condition before the question mark, what do we want to do if the condition is true, and what do we want to do if the condition is false. That is how the ternary operator actually works. So let's go ahead and see what it does. Right, so first I'll actually enter a number less than 18, so it should say the number is less than 18. Perfect. Let's try it for the other way around. I'll enter a number which is greater than 18, say 25, and it says the number is not less than 18, right? So there we go, that is working just fine. So that is what the ternary operator is all about. You can actually have multiple ternary operators, or something called as a nesting of ternary operators, which means you can have a condition inside a condition. Here you can have another ternary operator with a question mark, colon, and a semicolon in brackets, of course. But this gets a bit confusing after a while, so the maximum number of ternary operators which we can actually use are 2, because then it gets really complicated. So there is another very interesting way of making decisions, which is something called the if else and the switch case, which we will be talking about in the next few tutorials. So go ahead, try it out, and I'll see you guys in the next one. Alright, so if you guys remember, in the previous tutorial we talked about something called as a ternary operator, which basically helped us in making decisions. But the problem which we were facing there was that if you wanted to have more than one choice, the things were getting very complicated. So I told you guys that we have something called as if else and switch case for dealing with those issues, right? So in this tutorial we'll be talking about the if else, and in the next one we'll be dealing with the switch case. So again, what we are going to do here is we'll give the user 4 choices, and we'll simply say whichever choice the user chooses, we'll say you chose this particular choice, right? So that's the code which we will be making here. So let's make an integer variable for reading the choice, and we'll actually go ahead and we'll display 4 choices for the user. So we'll say here's the menu sounds good to me, and we'll say one name, we'll give a tab, and age we'll give another tab. I'll say company, and exit. Right, so those are the 4 choices which we'll be giving to the user. Now what we are going to do is, if the user enters choice 1, we'll simply say you wanted the name. If the user enters choice 2, we'll simply say you wanted the age, and similarly for other 2 choices. Obviously if the user chooses choice 4, the program should exit, right? So I'll also be telling you guys about something called as the exit function in just a minute. So let's go ahead and read the choice now. we'll say enter your choice, my bad, and we'll be quickly reading the value for choice and storing it in the variable choice. All right, so now what we have done so far is we have displayed the menu here, and let's actually print it on the next line. It looks a bit beautiful that way. So we have actually printed the menu and we have taken the choice from the user. Now what we need to do is we need to check whether the choice is equal to 1 or 2 or 3 or 4, whatever value the user enters. Right, so we have 4 conditions here. We need to check the condition 4 times. Now if you actually go ahead and try doing this using the ternary operator, I bet 90% of you won't be able to do it, and the remaining 10% will be able to do it, but then it will get very complicated. So there is another very interesting way of doing that, and that is something called as the if-else construct. Now if-else is actually a single unit, it is not two different units, so to say. But what we can do is we can have the if without an else, but we cannot have an else without an if, right? So if can exist individually, but for an else to exist it should necessarily have an if before it, right? So this is the most basic syntax of if. The keyword we use is if, and there is this condition in the brackets, and whatever we want to do if the condition is true comes between these two curly braces. Now whatever comes in between these two curly braces we call it a block, right? The curly braces along with the code in between is referred to as a block, so we call it the if block since we are dealing with the if a construct here. So let's enter the condition if choice is equal to 1. Now again, in the operator video I told you guys that whenever we need to compare any value we need to use double equal to, because single equal to means assignment which is always true, right? So what this means is that if the value of choice is equal to 1, go to the block and do this. So we'll say you ask for a name. Okay, so that is all we'll be saying in this. Now let's do something very simple very quickly so that we understand the else case. What happens is that if choice is equal to 1 we'll be doing this, and if we have something to display when the choice is not 1 or when this condition is false, right, that is where the else case comes in. We have else and we have the else block here, so we can actually go ahead and print you asked for a name. So we'll just say you did not choose 1, right? So that is what the if else looks. Basically, if the choice is true, do this. If the choice is false, or else, as we talk in normal English, do this. So if this is true, do this, else do this, right? But actually in our case we need not use else just yet. We need something very interesting apart from the else. That is something called as the if else if ladder, right? Now since we are dealing with 4 choices here, what we need to do is we need to nest these things. So we'll enter another if inside an else and say if choice is equal to 2, then do something, right? And again else here, and we'll again say if the choice is equal to 3, do something. So that is how we'll be going with all the 4 choices. Now if you guys observe closely, we get something, a sort of a ladder, right? If, so this becomes a ladder. Now what happens when we remove these braces? Let's see what happens when we remove all the braces. That is where we get something called as if else if ladder. So there we got rid of all the braces, and let's get rid of the space between them as well, right? So perfect. So that is how the if else if ladder works. If choice is equal to 1, do this, else if choice is equal to 2, do something else, else if choice is equal to 3, do something else, right? So this is what the if else if ladder looks like. Again, if the choice is 2, we need to print that you asked for age, alright. And if the choice is 3, we need to print you asked for the company, right? So let's go ahead and do that for the company. Few typos here and there, cool. And now we are done dealing with all the 3 choices, and we have only one choice left. So instead of another else if, we'll simply add an else, and we'll print that you chose to exit, and we'll be using something called as the exit function here. The syntax of exit function is this: exit and 0 here. Now I'll tell you guys what the 0 stands for. 0 is basically a code or a symbol which is returned to the operator, which basically means that there was no error while this program right, while this program actually quit. Because what happens is that if you enter a 1 or a negative integer here, the operating system actually searches for the error which caused this program to close, right? But while we are passing 0, we are telling it that, hey, don't worry, we closed it intentionally, there is no error, right? So that is what the exit function looks like. So let's try the code out now then. Okay, so enter your choice. Okay, I'll say 2. So it says you asked for age, which is exactly what I wanted it to, and I missed a T here. That was why it was showing abruptly in the previous one. Okay, now let's actually go ahead and try using the exit function. So I'll say 4, and as you can see, you chose to exit was displayed and the process exited with return value 0, which basically means that there was no error, right? So that is what the if else construct looks like. Again, quick recap: we can use an if individually, but whenever you're using an else, you need a preceding if, right? So also we discuss something called the if else if ladder, which comes very handy when we are dealing with multiple choices. So if you have only one choice, you can go ahead with if, but if you have multiple choices, the if else if ladder is recommended. But again, if the number of choices is more than say 5 or 6, this also becomes very lengthy and complicated. So that problem is taken care of by the switch case, which we'll be talking about in the next one. So now you know how to make decisions. Go and try some piece of code out, and I'll see you guys in the next one. Welcome back to the next tutorial. Now, as I said in the previous one, that we will be dealing with switch case in this tutorial. So what we'll be doing is we'll be making exactly the same piece of code which we made in the previous one using switch case, so that you guys can easily differentiate and understand as to why switch case is preferred in certain cases than the if else. So let's go ahead and read a choice from the user again. Here's the menu. Now why I am writing all this again is because I want you guys to get accustomed to the basic functions which we use, like printf, scanf, etc. So again, we'll enter a new line: name. The second one was age. The third one, I guess, was company, right? And the fourth one was obviously exit. Great. So now we have displayed the menu. Now we'll ask the user to enter the choice. And we'll be reading the value of choice. So %d ampersand choice. Okay. Now we have the menu, we displayed the menu, and we took the choice. Now we need to take a decision, right? We need to decide what choice the user entered and what do we want to perform an action accordingly. So now we'll be using the switch case. The basic syntax of switch case is this: we have switch condition, and inside the block we have multiple cases, right? This is the basic syntax of a switch case. So the condition, or basically here what we enter is the variable which we are going to compare, right? So we need to compare the value of choice with 1, 2, 3, 4 and decide accordingly, right? So we'll enter choice here inside the brackets. So what this means is that we'll be switching the value of choice in a literal sense, that we'll be checking the condition for each and every case. So if the choice is 1, we'll write case 1 and we'll do something. If the choice is 2, we'll write case 2 and we'll do something. If the choice is 3, we'll write case 3 and do something. and if the choice is neither of those, we have something called a default case, right? So if the choice is 4, we'll execute the default statement, right? So let's go ahead and again write whatever we wanted to. So we wrote something like you chose the name, and I just copy this and use it for the 2 and 3 as well, and for the default case as well. So here we need to modify it to age and company, and you chose to quit or exit, whatever. Okay, so now this looks good. So now what should actually happen is that if we enter 1, we should get only this line as the output, and if we enter 2, we should get only this line as the output, and so on and so forth. So let's actually go ahead and see if that happens or not. Well, I am sure you will be surprised with the result. Okay, so what I'm going to do is I'm going to enter the choice as 2. So there we go, I entered the choice 2, but hey, what is the output? You chose the age, you chose the company, and you chose to quit. Is there something wrong with the compiler? No, absolutely not. What happens is that in switch case, there is something unique. What that is that if any of these choices satisfied, or if any of these cases satisfied, all the cases below it till we reach the end of the block are executed. So since in this case we entered 2, and so case 2 was executed along with all the cases following it till the end of the block, right? So now how do we get across this problem? There is something called as a break keyword. So what break basically does is it takes the control out from the nearest block. So in this case the nearest block is the switch block, or the innermost block is the switch block, right? So the break will basically transfer the control from here to outside of the block, which is here, and since we have no code here, so the program should quit automatically. So let's go ahead and add break to all of these cases. And this is a very, occasionally happens while using switch case. We forget the break keyword most of the times, and there is a special name given to it, which is something called as a fall through, which basically means that the code will fall down till the end if you do not use a break keyword, right? So that is a funny technical name given to this problem. Okay, now we do not actually need to add a break in the default case, because there is nothing after the default case, so it will actually quit after the default case automatically. So now let's go ahead and run the code and see if it runs as we want it to. So now again, if I enter choices 2, I should get only age, and there we go, we get you choose the age. Perfect. So now since we also wanted to quit the code, we can use the exit function here as well. Great. And there is one last thing, that is that these cases need not be in any serial order, right? Like we have case 1, 2 or 3 here, we can have case 3 in the beginning, or we can have case 3 in the middle of these two. These can be in any jumbled order. And another important thing is that we can either have integers, or we can have floats, or we can have characters. So we can have three sorts of cases. We can have integers, floats, or characters, right? So it supports all the three conditions. So if the value of choice is say 1.1, then this will be executed. If the value of choice is a, which is not possible in this case since it is an integer, but still if you say are using it in some other piece of code, so that is what the switch case supports. It supports integers, floats, and characters. And that is the advantage of switch case over if else, because you can compare floats in if, but it is a bit difficult to compare the characters, right? So let's say we want to compare it from A to Z. So how many times you have to write if, else if, else if, else if, and it will go on and on, right? So that is all about the switch case. Go ahead, try it out, and I'll see you guys in the next one. Okay, so welcome back to another tutorial. Now in the previous few tutorials we talked about how to make certain decisions while we have a number of choices, and from this and the next three tutorials I guess we'll be dealing with something called as loops. Now what is a loop? A loop is basically a given set of statements or a block repeated a number of times. So say you want to display numbers from 1 to 10 or characters from A to Z. So you will not actually write, uh, 26 printf statements for displaying A to Z. There has to be a much simpler way of doing that, and that is where the concept of loops come in. Now C basically has three loops: the for loop, while loop, and the do while loop. And in this one we'll be dealing with the for loop. So let's get started. The basic syntax of a for loop is this: we have for followed by a bracket and a block, right? And here we have something called as the initialization, then we have a semicolon, then we have the condition, then we have a semicolon again, and we have something called as updation or incrementation, right? So that is the for loop in its most minimal form. Now we don't actually write these words here because they are not keywords. We write whatever the numbers we are dealing with, right? So let's say we want to print numbers from 1 to 10. So how will we do that? So we'll just take a loop variable, something called as a loop variable. Now what is a loop variable? Basically we need to determine the number of times we need to run a particular loop, right? So let's say if we want to display numbers from 1 to 10, so we need to make the loop run 10 times. So in every single run we'll check the value of I, and once it reaches 10 we'll stop. So this is basically sort of a counter which will monitor the number of times our loop runs. So let's say we start with 0 and we want to go till 10. So if you want to go till 10, we'll have to make it equal to 10 or we'll have to make it less than 11. Either way, equal to 10 sounds good to me. And we'll have to add 1 to i's value. Now if you guys remember, this is the unary plus operator which I told you guys in the operators tutorial, right? So what this basically means is that whatever is there between this block will run 10 times. It will start from 0 and it will go till 10. So basically it will run 11 times, right? 0, 1, 2, 3 up to 10. So we simply need to print the numbers. So we'll just go ahead and we'll display the value of I. So we'll just add a tab in there and we'll simply display the value of I, because the value of I will start from 0 in the first case. Let me quickly explain you the flow of the loop. So when the program reaches the for loop, first it goes to the initialization part. So it initializes the value of I to 0, or it assigns 0 to the I value, and then the next step is the condition check. So it checks for the condition: is the value of I less than or equal to 10? The value of I is 0 and 0 is indeed less than or equal to 10. So if the condition is true, it goes to the loop body or the block and it displays the value of I. Now once it's done displaying the value of I, it goes to the updation part here and it will update the value of I with 1. So now the value of I is 1. The next step, again it goes to the condition check. So what this means is that the initialization takes place only once at the beginning of the loop. Now the value of I is 1 and 1 is again less than or equal to 10. Condition is true, it will again execute the body. It will again go to the updation. The value of I is 2 in this time. Then again 2 is less than or equal to 10. So again this body will be executed and it will go on till the value of I reaches 10. Now once we are on 10, 10 plus plus will mean that the value of I is 11, and now this time when it checks the condition, the value of I is not less than or equal to 10, which means the condition is false. So now what it will do is it will transfer the control to the line following the ending block, right? So it will basically transfer the control here, and since there is nothing here, the code will exit. So that's what this piece of code does. It repeats this particular line, the printing of I, 11 times. So let's go ahead and see what the output we get. Okay, so we get 0, 1, 2, 3, all the numbers right to 10, and that is exactly what we intended to do. So you can see how easy it is than writing 11 printf statements. You can just do it in one single line. So that is what the for loop looks like. Again, there is no limit to for loops. You can have for loops inside a for loop, which is called nesting. Basically a loop inside a loop is called nesting. So what will happen is that the inner loop will run. Let's say we have another variable j and we have it less than 4, j plus plus here, and if we have the j block and if we print the value of I inside j, what will happen is that for every value of I, that is when the I is 0, J will run 4 times. Then when I is 1, J will again run 4 times. So this loop will basically run 11 into 4, that is 44 times. It will print alternate values, right? So it will basically print I value 4 times, then it will print, which means it will print 0 4 times, then it will print 1 4 times, and so on. So let's actually go ahead and see this as well, so that you guys have a clear idea of whatever I'm saying. So there you go, as you can see we have 4 zeros, 4 ones, 4 twos, and so on until 4 tens, right? So basically this nested loop ran every time, like 4 times for every I value. So that's what a nesting of loops looks like. We do use this in arrays, which we'll be dealing with in a next section. So again, this is the for loop of for initialization, condition, and updation. You can even have decrement here, right? There is no such thing as only incrementation or something. You can have anything. You can have I is equal to I divided by 2, or any other modification which you want to make, right? So that's all about the for loop that I have for you guys. So thank you guys for watching. I'll see you guys in the next one. Okay, so welcome back to another interesting tutorial on loops. Now in the previous tutorial we talked about the for loop, and I said that we'll be dealing with the while loop in this one. Now I don't know why, but people are actually scared while using the while loop, and that is because there is a reason which I will not tell you guys right now. You will understand it hopefully till the end of this tutorial. So there is a very slight difference between the for and the while loop. The functionality is almost similar, but the syntax is a bit different. So let's take a look at the syntax of a while loop. Again, we have the exact same basic outline, but if you guys remember, in the case of for loop we had three things, right? We had initialization, we had something called the condition, and we had updation, and all of them were together inside this bracket, right? But in the case of while loop we have the initialization before the body of the loop, if I can spell it right. Okay, initialization, then we have the condition in here, and we have the updation inside the body of the loop, right? So that is the basic syntax of a while loop. And again we are going to make the exact same piece of code which we made in the previous one, so that you guys can relate and understand why people are afraid of using the while loop. So we'll initialize the value of I to 0, and if I remember correctly the condition was I was less than or equal to 10, and we will go ahead and we'll display the value of I and I. Now before we forget, we need to update the value inside the loop. Now updation is usually the last line, because you know whatever you want to do, you do it in here, and before exiting the block just go ahead and update it. So let's quickly run this and see, and I'll explain you the flow once we see the output. Okay, so we got the exact same output as the last one. So again let me explain the flow once again. As in the case of for loop, the initialization is carried out exactly once and only once. In the for loop it was in here, but in the while loop it basically looks like it is not a part of the loop, which is how it should be, because you know it is executed only once, and loop statements are supposed to be executed repeatedly. Now again, once it is initialized, the condition is checked and the loop body is executed, updation takes place, again the condition is checked, body is executed, updation takes place, and this goes on till the condition is true, right? So I'll also tell you guys quickly about the nesting in the exact same manner which we did for the for loop. So let's make another loop variable j, and now here's something very important. Before actually writing this another while loop, what we need to do is we need to initialize the value of j as well, right? So if you initialize this, the value of j right here, you will definitely not get the expected output. So let's actually go ahead and see the wrong output, so that we understand what is actually happening in here. And again we'll update the value of j inside the j's block and not in the I block, right? So make sure that you update the value of j inside the j block and the value of I inside the I block, which basically means outside the j block, right? So let's again run this piece of code. In the previous one we got 4 zeros, 4 1s, 4 2s, up to 4 10s, right? But here we got only 4 zeros. Now that is because of the initialization. We did not initialize it at the right place. Let me tell you the flow of this piece of code and then we'll look at the correct one. So what happens is that the I value is less than equal to 10, which is true because it is 0. So it goes inside the loop. Now it starts checking for j value is less than 4. Yes, the value of j is 0 for the moment. Okay, so it prints the value of I and it increments the j value to 1. Now 1 is less than 4, true. Again this happens and it goes on till 4 times. But now the value of j is 5, right? And the condition is that j is less than 4, so it will exit the j's body and it will again go to the i's body. And here I will be incremented to 1. The condition is indeed true and it will come back to the j's case. But what happened is that the j's value is 5 because we have not made it 0. So what we understand from this is we actually need to initialize the value of j just before the j's loop, because every time we execute the i's body we need to initialize or we need to re-initialize j to 0, right? Because every time we need to start with a 0 so that it goes till 4 times. So now if we run it, hopefully we should get the correct output. So there we go, we get 4 zeros, 1s, 2s and up to 10s. That is exactly which we wanted, right? So this is a very basic, because as I told you, we have the initialization before the loop, we have the loop body and we have the updation inside the loop body. So this is one loop and this is another loop. So that is how the nesting actually works. It is basically the syntax of one loop inside the syntax of another loop, and the inner loop is executed repeatedly till this condition is true, right? So 10 into 4, again it is executed, or sorry, 11 into 4, it is executed 44 times. So we get 4 values for each number, right? So that was all about the while loop. Now I hope you guys have understood how people are actually afraid of using it, because people mostly mess this up. They initialize it over here and they updation they do together, so they get some weird output. But as I said, there's nothing to worry. If you just pay a bit of attention, you can easily achieve whatever you want to. And while loop is basically fun to use because it is a bit challenging than the for loop. Apart from that, there is no difference between these two. So go ahead, try it out. Then in the next one we'll be talking about the do while loop, which is slightly different from these two. So I'll see you guys there. Okay, so welcome back to another tutorial. Now, as I said, in this tutorial we'll be talking about the do while loop. I hope you guys remember whatever we have dealt so far about the for and the while loop, because it is very similar to that, but there is a slight of difference between these three. Now, as I told you in the previous one, that for and the while loop are basically similar except from the syntax. The do while loop is actually a bit different when it comes to functionality as well. The syntax is similar to the while loop, but the functionality is quite different. So let's quickly look at the syntax of a while loop. We first have a do keyword and we have the body here, which again contains the updation as well. And we have the while here with the condition, and the initialization is of course done just before the loop. Okay, so that is the syntax of a do while loop. We have initialization, we have the do keyword, we have the loop body, we have the updation here inside the body, which is again mostly the last statement of the body, and we have the while keyword here with the condition in the brackets. That is what a do while loop looks like. Now, I hope you guys can see the difference, because what happens in case of while loop is that we check the condition at the beginning of the loop, but in the case of do while loop we check the condition at the exit of the loop, right? So do while is basically called an exit controlled loop. On the other hand, the for and while loops are called entry control loops. Now what happens in the case of the functionality is that in the case of a do while loop, the body of the loop is executed at least once, right? Because even if the condition fails for the very first time, it is not checked until the body is executed completely. So the loop actually starts without checking the condition for the very first time. You will understand this clearly if we again try to repeat the same piece of code with the do while loop this time. So let's actually go ahead and print the value of I. and we'll initialize I just before the loop, and the condition was I is less than equal to 10. Right, so this was the condition. Now let's see if we are getting the same output again or not. Right, why did that happen? Because we forgot to increment the value of I. Right, so the value of I was always 0, and we made something called an infinite loop. Right, so this time we should hopefully get the correct output, and there we go, we get the exact same output for the third time using do while loop. Brilliant. So now I'll tell you guys what is the difference in the functionality between the do while and the other two loops. The only difference in functionality is that in the other two loops, the first statement is initialization and the next is condition. On the other hand, in the case of a do while loop, the first step is initialization, but the next step is the loop body. So what this means is that the body of the loop is always executed at least once, even if the condition fails for the very first time, because the condition is checked after the body has been executed once. So here's the flow of the do while loop. First, the value of I is initialized to 0. The body of the loop is executed, that is, we print the value of I, and then the condition is checked. After that, the value is incremented, condition is checked again, value is incremented, condition is checked again, and it goes on till the condition is true. So again, the condition is checked after the first execution of the body. So even if the condition fails for the very first time, we will get an output whichever is there in the body, right? So this piece of code right here will be executed at least one always. That is the only difference between the for and the do while loop, or the for while and do while loops. Right, so that was all about looping statements in C. Now in the next tutorial, we will actually be combining whatever we have learned so far into one big program, and we'll try to make something really interesting. So I hope you guys are looking forward to that. I'll see you guys in the next one. Okay, so welcome to the last tutorial for this section. In this tutorial, what we'll be going to do is we'll be making use of all the concepts we have learned so far for making a very simple menu driven program. We'll basically be giving user a choice for the figure which he wants, right? So we'll be displaying various figures like circle, square, rectangle, etc., and whatever figure the user chooses will go on displaying the area till the user wants it to, which basically means that we'll need to repeat the menu many times till the user chooses to exit, right? So let's get started. The very first thing which we need is we need to display the menu. So let's go ahead and display the menu. Now I want you guys to pay a close attention to how I am arranging the code. I am doing it step by step. So very first thing is, which area do you want? Because you know the most important part of programming is how you arrange the code, right? How efficiently you arrange it, and that's what decides which code is better, right? So the very first thing I like is the circle here, then say square, and rectangle. So let's go ahead with three choices, sounds good. And fourth one will obviously be exit. Right, so there we have our menu. Now we need to take the input for choice, so we'll say enter your choice, and we'll read the value for choice. Ampersand choice. Now here we find that we do not have any variable named choice, so we'll go ahead and declare a variable choice. Now in C, the variable declaration is done at the beginning. So if you try to declare choice here, you will get an error and the program will not run. So make sure that all the variables which you need to make or use, you do it before any other piece of code here. Now why I did this is that why I did not initialize or declare choice before using it here is that I do not want to waste the memory space, right? So after coming here, I realized that I need a variable for storing choice, and that is why I went ahead and I initialized one. Because if I declare all the variables here from the very beginning, I might or might not use all of them, and that results in wastage of memory. So that's what I told you guys to pay close attention to this one. because I'm basically telling you guys how to think while coding. So since we needed a choice variable, we went ahead and we made one. Now the next thing which we need to do is we need to actually write some switch case or if else, whatever you guys want to use. So I'll go ahead with switch case here because we are dealing with four choices and I'm very lazy for typing that if else ladder. So I'll go ahead with choice, and case 1 will be printf the area of oh wait, before actually taking the area we need to take the radius of the circle, right? So we'll go ahead and we'll say enter the radius, and again we realize that we do not have a variable for radius. So we'll scan, and radius can be a floating point number, so we'll go ahead with float and we'll say radius. Now again we realize that we have not created the variable radius yet, so we'll go ahead and we'll make a variable called radius here. Okay, then now we can easily calculate the area. So we'll say the area of the circle is, and we'll display the value of area, which basically will be radius into 3.14 into 3.14, right? 3.14. Perfect. So pi r square, I hope I am right with the formula, right? And we need the break keyword again. And now for the second case we'll have to take the side of the square. So we'll enter the side, and again we realize that we have not created any variable for side. Now even side can be float, so let's go ahead with float. So we'll again go ahead and we'll make a variable called side. Now as you can see, I am making variables as and when I need them so that I do not waste memory space. So again we'll say the area of the square is, and the area of the square is side square, so I'll say side into side. Okay, and break again. For the third case now we actually need to take in two values. We need to take in enter the length and breadth. So instead of doing it in two statements, let's try doing it in one single scanf statement. So we'll write 2 percentage d here, or let's go ahead with percentage f only. So we'll write percentage f 2 times, and we'll write ampersand length and comma ampersand breadth. So that is how we actually take two values using the same scanf statement, and you can even take 3 to 4 values in a single statement. It is possible. Okay, then again we'll have a break statement, but before that we need to print the area. So we'll go ahead and we'll print the area of the rectangle is, the area of the rectangle is, we can deal with a few typos, no issues there. And we'll write length into breadth. Okay, looks good. And the fourth case is exit, so we'll go ahead with the default one here. We'll say printf you chose to exit or something. Cool. And now we are done with the switch case. So let's quickly take a look at whatever we have done so far. We have displayed the menu, we have taken the choice, and we have compared the choice values, and accordingly we have written the code for calculating the area. Excellent. Now the only thing remaining is that I said that we'll be repeating this piece of code till the user presses exit. So we basically need to add a do while loop in here. Now I'll tell you the reason why we are using a do while loop, because if you guys remember that in the do while loops video I told you that a do while loop functions in a certain special way, and that is that it is an exit control loop, right? We want to provide the user a menu. We cannot just show him away for the very first time, because whenever a customer enters a restaurant, he may or may not need eat anything, but he at least sees the menu, right? He checks the menu once, and if he likes something then only he will order. So similarly, we'll have to make sure that we display our menu at least once before the customer exits. So if you guys use a for or a while loop here, the condition will fail for the very first time and the loop body will not run even once. So that is the only reason we are using a do while loop here. And here we'll go ahead and add the while statement, and the condition will be while choice is greater than 0 and choice is less than 4, right? So that will be the condition for the while loop, because we have values of 1 2 3, and on the value of 4 the code should exit, right? So that's what this while loop will do. We actually don't need these brackets, so let's get rid of them. Right, so now the code looks good to me. Let's see if it runs or not. If we get any errors, we can fix them always. Okay, so now we see that the length and breadth is undeclared, so obviously we forgot to declare them. So let's go ahead and make two new variables by the name of length and breadth respectively, and there was no other error, I guess. So let's again run it and see. Perfect. Which area do you want? A circle, square, rectangle? I prefer square, because calculation of side square is very easy. So let's say I enter 4 here, I should get 16. So there we go. I get the area of square is 16.0000, which basically means that it is a floating point number. Now again the menu is displayed for me, so as I said, we'll be displaying it again and again till the user presses enter. So let's try using rectangle this time. So since we press 3 or rectangle, it is asking for the length and breadth. Let's say the length is 3 and the breadth is 6. The area is 18. Again I have the menu. Let's try the circle out as well quickly. So the radius will be 4, and I don't want to calculate this because I trust my computer and it will be right. And now let's go ahead and exit the code. So now since I entered 4, it's showing me that I choose to exit and the process return, which basically means that the code is complete and the program has quit. Right, so that is how you actually apply all the tidbits you have learned here and there for making one program. And just remember the flow, how I explained the flow, because if you have initialized everything at the very beginning and then you try to use them here, it becomes a very tedious task to actually monitor which variables we use and which variables are just wasting the memory. So make sure you declare variables as and when you need them, because you really don't need to sit down and count that I'll be needing these variables while beginning the code. So just go ahead with whatever you have in mind, and whenever you are confused with something, you can always go ahead and declare a new variable, right? So that was all about this tutorial for now. I hope you guys enjoyed it, and I'll see you guys in next one. Okay, so now that we are finally in section 4, now we get to talk about some really interesting stuff. We are going to be discussing something called as an array. Now, by definition, an array is a collection of similar data elements grouped under one name, right? But again, you won't understand anything from the definition just yet. Let me give you a simple example. Let us suppose we need to store marks of say 100 students in our class, right? Suppose we have 100 students in my class and I want to store the marks of all of them. So going by what we have learned till now, we'll be making 100 marks, say marks 1, marks 2. We'll be declaring 100 such variables, right? But that is not the most efficient way of doing it, right? There has to be a simple way in which we can do that. So that is where the concept of array comes in. Again, as I said, it is a collection of similar elements. So what we do is we use square brackets here and we give the dimension. Now this is called the dimension or the size of an array. What this basically means is that there is a variable called marks, right? Or there is an array called marks, which is of type integer, which is going to store 100 values in it. So this line basically reserves 2 into 100, that is 200 bytes in the memory. And how are they referenced? Again, the indexing starts from marks of 0 and it goes on till marks 99, right? So that is how the 100 values are represented in the memory. It begins with 0 and it ends with 99. So we need to make sure that the last value is not 100 or the number which we gave, but it is number minus 1. So that is the ending value. That is what array basically is. It is a collection of similar data elements, right, referenced under a common name. I hope now you get the definition. So let's try reading these marks and displaying them back. That's what we'll be doing in this one, right? In the next tutorial, we'll be talking about array in great detail. So let's keep it simple then. I want to read 5 marks and I want to display them back. Again, what do we do when we have to repeat a certain number of or a certain piece of code multiple times? We use loops, right? So in this case, we'll be using a for loop. You can also use a while loop if you want. So I need another variable for the for loop, right? So let's go ahead and ask the user to enter the marks of 5 students, right? So we need to scan those 5 marks. Again, we'll go and make a for loop less than 5 and I plus plus, and here we'll be reading those marks. So we'll say scanf percentage d and ampersand marks of I. Now this is the most important part. We need to mention I here because when the loops runs for the first time, the value of I will be 0, so the marks will be stored in marks of 0. In the next case, the value of I will will be updated to 1, and then we'll store the next value in marks of 1 and so on. So this loop will basically go on till marks of 4, right? So as I said, this will start from marks of 0 and it will continue till marks of 4. So that is how we will be reading 5 values in one single statement. Alright, so now that we have those values, let's go ahead and try to display them. So we'll again say, here's what you entered or something, and we'll just go ahead and print those values back. Now again, we'll need to print the same thing 5 times. So we need another loop for doing that. In this case, we'll be using printf, again percentage d, and we can give a tab here just for say simplicity, and we'll be saying marks of I. Right, so now I hope you understand why I used I here again, because we'll start displaying from marks of 0 and we'll continue displaying till marks of 4. Right, sorry, my bad. Right, so that is what our code is going to do. We'll be reading 5 values and we'll be displaying them back in how many, say 16 lines, right? Alright, so let's run this and see what happens. Okay, so it is asking me to enter 5 marks. Let's say we have a paper of 100, so let's go ahead and enter 5 random marks and one should fail. Let's go ahead at 40, and that is what we get. Here's what you entered and we get all the 5 marks: 80, 89, 98, 70 and 40. Perfect. Right, so that is the basic introduction about arrays. We use arrays to store similar data. Now in this case, we discussed only integers. We can store strings and floats using arrays as well. So again, this was the basic. In the next tutorial, we'll be dealing with arrays in detail. So thank you guys for watching. I'll see you guys in the next one. Okay, so welcome back to another tutorial on arrays. Now as we discussed the basics in the previous one, we'll be dealing with arrays in a great bit of detail in this tutorial. So let's do a 10-second revision, whatever we did in the previous one. We made something called a single dimensional array. Now there are basically 3 types of arrays. We have single dimensional, which we dealt with in the previous one. We have 2-dimensional arrays, and we have something called as a multi-dimensional array, right? So in this tutorial, we'll be talking about 2-dimensional and multi-dimensional ones. So let's get started. Now, what is the real world thing which we represent in 2D, right? We all know what 2-dimensional is. We have an x-axis and a y-axis in that case. So what is the mathematical equivalent of a 2-dimensional figure? Yeah, you guessed it right. It's something called a matrix, right? We have something called a matrix, which basically is 2 values. We have rows and we have columns. So this is basically the syntax of a 2-dimensional array. We have the number of rows here and we have the number of columns here. So that is how matrices are represented in C. Again, we need to give it a name, so we'll just call it matrix 1. So this is basically what a two-dimensional array looks like. We have 5 rows here and we have 4 columns here, which again gives it a total size of 5 into 4, which is 20 elements, which reserves 2 into 20, that is 40 bytes of memory for this particular array called matrix 1, right? So now let's do this. We'll read a matrix, or say we'll read two matrices and we'll add them. So that's what we'll be doing in this one. So let's make another array here with another matrix. Now as we know, the condition for adding two matrices is that the number of rows and columns should be equal, right? So we'll be needing two variables here because we are dealing with a two-dimensional array for the loop. So again, let's go ahead and make a for loop real quick. We have 5 rows, so I'll go with I plus plus here. Now inside the for loop, we'll make another for loop, a nested one, because again here we have to use j. Let me quickly finish up the syntax, so I'll explain you what we are doing exactly. And here we'll be reading the values, so %d and ampersand matrix 1 I and j. Perfect. Now let me quickly explain you what I wrote here. With the very first time when this loop starts, the I value will be 0. So when the I value is 0, the j loop will again run 4 times, right? Then the I value will be incremented to 1, and again the j loop will run 4 times. So basically this I loop will run 5 times in total, because we have 5 rows here, and this j loop will run 5 into 4, that is 20 times in total, because we need to take 20 values, right? We need to read 20 values and store it in the matrix. Again, the reason for using ij here is that when the value of I is 0, we'll have 4 values of j, right, from 0 to 3. Then again when the value of I is 1, we'll have 4 values of j again. So this will keep repeating for 5 times until we are done reading 20 elements. So let's go ahead and copy this and paste it again for the another matrix as well. So I'll quickly change the name here to matrix 2, and let's add a message for the user here telling them what they exactly need to do. So we'll say enter the elements, okay, of the first matrix, and we'll read the elements. Again here we'll say enter the elements for the second matrix. Right. And finally what we'll be doing is we'll be adding these two matrices and we'll be displaying the sum. And again we'll try to display it in a matrix format, which is a 2D format. I'll tell you guys how in just a while. So now we need another loop for adding these, right, because we need to perform 20 addition operations here. So we'll again start with 0, we'll go to 5, we'll increment I, again we'll nest this loop with the value of j, right, and here we'll, now since we need to add these matrices, we need another matrix where we'll store the results. So let's go ahead and make another matrix real quick. Now again the size of the resultant matrix also should be the same, that is 5 rows and 4 columns, because matrix addition is dependent on rows and columns only, right? So the case is different with multiplication. So when you do multiplication, you need to make sure that the number of rows of the first matrix is equal to the number of columns of the second one, right? Okay, so now we'll be adding those values. So we'll say matrix 3 is equal to, or we'll have to give ij here. We'll say matrix 3 ij is equal to matrix 1 ij plus matrix 2 ij. There we go, semicolon at the end. Let me make sure everything is correct. Okay, we named it matrix, so let's go ahead and change the name to matrix 3. Alright, so now we have the resultant matrix here. Now we need to display it back. So again we need this loop. So I'll quickly copy it here. And instead of adding, we need to go ahead and display the values of matrix 3. Now I'll tell you guys a quick trick to display it in a 2D format. So again in J's loop body, what we are doing is we are displaying the elements of the entire row, right? and we'll be changing to the next row in the I loop. What I mean is that for the first row we'll be displaying the entire elements in this loop, then again for the second row we'll be displaying the elements inside it, right? So here we'll basically print the elements and we'll add a new line in the I's body. So here we'll say matrix 3 and I and J. There we go. And outside the J's body, but before the closing of the I loop, we'll add a new line. So we'll just say printf /n, and that should add a new line. Alright, so let me make sure I didn't mess anything up. Okay, everything looks good. So let's go ahead and run this and see if it actually runs. Okay. Alright, we missed the semicolon here. Right, so enter the elements of the first matrix. Now again matrix elements are entered row wise. So I'll say 2, 3, 4, 5, 6, 7, 8, 9. I need to give it a number of elements because we entered a 5 by 4 matrix. Right, so just me randomly add some elements, and for the second matrix as well. Right, so that is the resultant matrix. Right now, as you can see, it has been represented in the actual matrix form. This is the first row, this is the second row, this is the third row. So that happened because we went to new line after the ending of each row, right? The row was printed here, and after that, before printing of the second row, we went ahead and we made a new line character, right? So that is how this 2D sort of a representation is done. So that is it about the two-dimensional arrays. Now there is actually no limit to dimensions. You can have a 3D array or a 4D array. The actual size has not been specified, and C does support arrays up to 10 dimensions. I read that somewhere, I did not try it out actually. But again, if you make a 3 by 3 array, what happens is that the total number of elements is 5 into 4 into 3, which is equal to 60 elements. Right, so that is how it goes, and again you need to add 3 loops here for reading the 3-dimensional array, and the number of loops should be equal to the number of dimensions you are having. So that was all about arrays. Now there is only one thing left, which is something called a character array or a string, and I'll be telling you guys about that in the next one. So thank you guys for watching. I'll see you guys in the next one. Welcome back to another tutorial on arrays. Now in the previous two tutorials we talked everything about integer arrays, and in this one, as I said, we'll be dealing with character arrays or strings. So we have learned so far as to how to take inputs for single digits, right, or single characters like A, B, C, etc. But how do you actually take a word, or how do you actually store a word or a name in the memory? So again, as the integer array was a collection of integers, a word is basically a collection of characters, right? So that is how we deal with it. A word or any name is stored in the memory in the form of a character array, which is again similar to the integer one. We have the char keyword, which stands for character obviously, and we have the name for an array, and we have the length or size, or the dimension, whatever you want to call it. So again, what this statement means is that we can store a word which has 5 characters, or whose length is 5 characters. So now there are a bit of differences while reading a character array or a string and a normal character. Let's ask the user for the name. So we'll say enter your name, and while reading it there is a slight difference. What we need to do is we need to use %s at the very first place. S stands for string, so that is how you actually read a character array with this %s, and you need not enter the ampersand symbol here, so you can directly go ahead and write str for reading the input. So that is, again there are two differences. The very first thing is, instead of %c we use %s here, and we need not use the ampersand symbol. Even if you use it, it works just fine, but it is not recommended using it so as to differentiate it from the other inputs. So let's try and displaying it back. So we'll say your name is and let's go to next line here, look a bit neat, and we can print it right here. Again we'll say percentage s and we'll write str. Okay, so that is all we need to do for reading a name or a collection of characters or a word. So let's run this and see what we get. Enter your name. Now again, since we have this size as 5, we cannot enter more than 5 characters. Even if you do, it will simply consider the first 5 characters. So my name actually fits in those 5, so let's go ahead and see. So your name is Aquib. Perfect. That's how we deal with characters or character arrays in C. So that is all about character arrays. Actually there's nothing much to say except these two differences. So keep in mind, the very first thing is the percentage s instead of the percentage c, and again you need not use the ampersand here. So go ahead, try them out, use them in whatever program you're making, and I'll see you guys in the next one. Okay, so welcome back to the last section of this course. Now, as I said, in this section, we'll be making one big project and we'll be implementing everything we have learned so far. So what we are going to do is we are going to make a CGPA calculator, right? So instead of me telling you everything about what a calculator does, let's start working on it and you guys will understand everything on the way, right? So the very first thing which we need is we need the database of a student, right? We need the name, registration number, and we need marks. So let's go ahead and take care of that first. Now we'll be storing name in a character array, right? So let's go ahead and make a character array. We need marks in say 5 subjects. So we'll again make an integer array with 5 subjects, and we need a registration number which let's assume will be an integer. So we have made the basically a database for a student, right? So let's actually go ahead and take all these values from the user. So we'll say enter the following details and take the cursor to the next line. Name, and we need to read the name, so we'll use the scanf here, and in case of a string we use percentage s and we need not use the ampersand symbol, right? So there we have the name input. Next we'll read the registration number. And we'll again use the scanf statement for reading it. Since we are dealing with an integer, we'll go with percentage d and ampersand reds now. And finally we need to read an integer array for which we need a for loop, right? So let's go ahead and make a loop variable. So we'll start it with 0 and we'll go till 4, which adding 1 every time, and we'll be reading all those values. Since they are integer values, again we'll be using percentage d here, and we'll be using marks of I, right? So now what we have done is we have taken care of all the inputs. We have the name, we have the registration number, and we have the marks as well. The next thing which we need to do is we need to calculate the average of these marks, right? So what we are going to do is, if the average of these marks is between 90 and 100, a CGPA of 10 will be given. If the average is between 80 and 90, a CGPA of 9 will be given, and so on, right? So since we are dealing with average, we need a floating point number for storing that, and again we'll use a for loop because we have 5 different marks, so we'll need to add all of them while taking an average. So let's make a for loop again, and now what we'll do is we'll do average is equal to, now here we understand that we are dealing with one more problem. How are we supposed to add those 5 marks, right? So for that what we can do is we can make a temporary variable, right? We'll just name it temp, and before actually calculating the average, what we can do is we can add all those 5 marks and store it in temp. So what this statement here will do is it will basically add all the 5 marks and put it in one single variable called temp, right? So temp is equal to temp plus marks of 0. In the next step, temp is equal to, now temp will basically be marks of 0 plus marks of 1, and so on. So this will basically add all the 5 marks into one variable. Now we can simply go ahead and average will be equal to temp by 5, right? So that is what our average will be. Okay, so now the next step which we need to do is we need to compare these values, right? As I said, if it is greater than 90, we'll say that the CGPA is 10. So again we need another integer called CGPA. So let's go ahead and make that. And now we'll be using the if else if ladder. So we'll say if average is greater than 90, CGPA is equal to 10, right? Else if, now as you can see here, I did not use any block. What happens is that if you have only a single statement after if, you need not make it in a block, right? Similarly here also we can remove these braces and we can write the single statement following it. But let's leave whatever we have done as it is and continue with our thing. So if average is greater than 80, CGPA is equal to 9. Now I want to highlight something here, and that is I am not writing that average is less than 90 again here, because if the value of average is 85, so 85 will not satisfy this condition and it will automatically come down here. So we need not worry about, adding another condition here like and average is less than 90, because when the average is greater than 90 it will automatically go to the first condition, so we need not worry about this. So let's get rid of that. Right, next again, else if average is greater than 70, we'll be giving a CGPA of say 8. Else if average is greater than 60, the CGPA is equal to 7. Else if average is greater than 50, CGPA will be 6, and anyone below 50 will fail. So we'll write else and CGPA equal to 0. Right, now let's actually add one more thing here. What we'll do is, if the CGPA is 10, we'll give the person a grade S. If the CGPA is 9, we'll give them a grade A, and so on, right? So now instead of using the if else if ladder, let's make use of the switch case. So we'll switch CGPA, and now as I said, we need to put the grade, so we need a character here. So we'll go ahead and make a new character with the name grade, right? So now let's go ahead with a switch case and write all the conditions. Case 10 here, because when the CGPA is equal to 10, we'll be dealing with a grade. So we'll write grade is equal to S, right? And we need the break statement as well. Now case 9, grade is equal to A. Again we'll need the break. Case 8, grade is equal to B. Break again. Case 7, grade will be C. Break. Case 6, grade is equal to B. Break, and everyone below 6 is fail. So we'll write the default case, which will say that grade is equal to F. Right, so there we go. We have also given the student a grade. Now we'll simply display the result. So we'll say the final CGPA is, now let's actually go ahead and put it in the next line, and we'll write percentage F, since CGPA is a floating point number, and we'll say CGPA. Oh wait, CGPA is an integer, right? So we'll go ahead with percentage D, and we'll also say printf the result print grade is, or the grade allotted is, whatever you guys want to write. We'll say percentage C, and we'll display the value of grade. So that is what the program should do, it should display the CGPA as well as the grade. So let's actually run this thing and see if it works properly. We need to save it before it runs. So I'll save it as cgpa.c, and now let's go ahead and execute it. Hopefully we get a few errors. Oh my god, we have no errors. Wow, that is amazing. So enter the following details. My name is Aquib and my registration number is say 17. Alright, why is this happening now? Okay, enter the following details, and we did not give any prompt for the marks here, so let's actually go ahead and close it and work on it before we try it out. So we'll go ahead and we'll say enter the marks in 5 subjects. ECTS, right, and that sounds good to me. Okay, now here's a quick tip. The scanf actually places the cursor to the next line automatically, right? So why I did this manually here is that there is no scanf here, so the name will come to the next line because of this \n. But as you saw, registration number was automatically on the next line, and that is because scanf automatically moves the cursor to the next line when it reads the value, right? Okay, so let's run it again. Thank God we got an error. Wow. You know, the more errors you solve, the better you get. And I realize that I have not placed a semicolon here. So let's try it out again. Perfect, it's running fine. Again, I'll enter my name, I'll enter the registration number and enter the marks in 5 subjects. 89, 87, 67. Okay, so that program exited with an error, and here is the reason why we missed the ampersand. As I told you guys, ampersand is very important. Let's try it out again. 17, 78, 89, 87, 67 and 50. Okay, so final CGPA is 8 and the resultant grade is B. Oh shit, I did very bad in the exams. Alright, so that is what we made here. We made a simple basic CGPA calculator, and now I'll tell you guys something very interesting by which you can share this thing with every single person you know, right? So now we are working in the Dev C++ software, right? So we are running our code only here. We don't know how to actually use it outside the software. So what if I tell you guys that you need not do anything else? You can use this code directly right now. So what you can do is just go to file, go to save as, and just look at the location wherever you have saved it, right? So it's saved in my computer and it's saved in section 3. So what I'll do is I'll quickly go to that location on my computer. So there we go, we have our CGPA file right here, and we have something else also. That is something, if you go ahead and you check out the properties, you will see that it is a .exe file. Now 90% of you guys might know that .exe is basically used for executing programs throughout the Windows platform, right? So let's actually run this and see what we get. So when we open the .exe file, we get our program right here. So that is what I meant. We never made the CGPA file or the .exe file by our own, right? What happens is that whenever we compile our program and whenever it runs successfully, the Dev C++ software automatically makes a .exe file for us to use. So that is where we get the .exe file from, and now this file can be used anywhere on any laptop without any software, right? You need not have a Dev C++ software or anything. Just like normal exe files, you can use this .exe file also for running your code. So now, and if any one of your friends wants the CGPA calculated, you can go ahead and give them this thing. So that is how you actually make a program. You get a few errors in between, and you should get a few errors in between. An error-free code. I don't support an error-free code because, you know, the more errors you solve, the better you get. So that's all I have for you guys in this tutorial. Hope you guys liked it. Go ahead, make your own thing. Alright, so thank you guys for watching. I'll see you guys in the next one. Okay, so welcome to the very first video of section 1. Now I hope you guys are already familiar with whatever is written here, because we'll not be talking about this. In this section we'll be dealing with data types again, but let me tell you that we'll not be talking about what an integer or character is, because you guys probably know that. So in this video I'll be telling you guys some really interesting things which you can do to modify the data types according to your specific requirements, right? So suppose I am going to take age as input. Now I know that age can never be a negative number, right? So is there a way of telling the compiler that don't expect a negative number here, or the age is always going to be positive? Well, yes, we can do that very easily, and that is what we'll be talking about in this video. So let's get started. As we all know, there are four primitive data types: int, char, float and double. There is void as well, but void cannot be modified, right? These four are the ones which can be modified, and there are four modifiers available with us in C, and those are short, long, signed and unsigned. Now as you can see, all of them are bolded, so which means that all of them are keywords, right? So let me first tell you the overview of what each does, and then we'll be talking about the specifics, which includes the bytes of memory, the occupy and the range, right? So let's get started with short. Now what short basically means is that all the default ones. So suppose we say int a. Now this is short by default, right? You need not mention the word short explicitly, but even if you do, that is what short does. All the default values and ranges are short. Next is the long. Now long is basically used to increase the range. Let us take the case of integer. We know that the range of integer is -32767 to +32768. So if we use long int, this range will be extended a lot. I'll tell you the specifics in just a minute. So long is basically used to extend or increase the range of any of these four, right? Next we have signed. Now signed basically means that the number can be a negative or a positive number or zero, whatever, right? It can be any one of these. On the other hand, unsigned specifies that this is going to be a positive number always. So if we write unsigned int a, it basically tells the compiler that int a will never be a negative number, it will always be either 0 or a positive number, right? So that is what unsigned stands for. Now that we have a general idea of what these do, let me actually tell you the very specifics with the help of this image which I've got right here. So as you can see, we have several different classifications here: signed, unsigned, short and long. Everything is included here, even the default ones like float and double. So let's quickly go through this table. The range for signed char is -128 to +127, while the case of unsigned char, which is always positive or 0, so it is 0 to 255, right? So that is what signed and unsigned do. Again, as I said, the default range of short is this, but when you increase it to long integer, the range is increased a lot, right? And even the memory space is increased. Similarly, for long double, the range is this and the size is 10 bytes. Again, we use different formats for different variables. So suppose we are using char, so by default it is C, right? In the case of long int, on the other hand, it is LD. And similarly with long unsigned int, it is LU. So as you can see, again, these are the negative numbers, but when we go to unsigned, all the numbers are positive, so the range basically doubles when we are dealing with unsigned, right? So go through these values, and that's what these four modifiers are used to do. So that's all I've got for you in this one. Thank you guys for watching. I'll see you in the next one. Okay, so welcome back to the second tutorial. Now in this tutorial we will be talking about something called as a storage class. Right, there are four different storage classes available in C, and that is what we will be looking at in this video. Now why do we actually need a storage class, right? What is the role of a storage class? As you know, there are two types of memories where the variables can be stored. The first one is the main memory, and the second one is the register memory, right? There are several registers which are used for faster processing of data. So it is possible that we can store the most frequently used variables in our program in the register so that our program performs faster, right? Apart from that, a variable storage class tells us what will be the initial value of the variable, right? So when we declare variables randomly without any storage class, what happens is that they are allocated a garbage value. So it is possible to initialize them with the value 0. right? The next thing which the storage class tells us is the scope of a variable. When will it be created and when will it be destroyed? And the last thing is it will tell us about the life of the variable as to how long does it actually stay in the memory, right? So there are four different storage classes available, that is automatic, register, external and static, right? So we have these four storage classes. Now as you can see, two of them got bolded and two did not. That is because the keyword for automatic is auto and the keyword for external is extern. So let's begin with auto. All the default ones which we do are auto. It is stored in the main memory or the CPU memory, and the initial value is the garbage value. It is created whenever it is initialized and it is destroyed. If it's inside a block, it is destroyed as soon as the block is over, and if it is not inside a block, it is in the memory till the end of the code, right? Register variables on the other hand are stored in the register memory, right? We have several different registers available depending on what architecture of your hardware is. So these registers basically are used for faster processing of data, and if you store the variables there, they can be retrieved faster and the time efficiency can be increased. Extern is basically used when we are using a single variable in more than one program. So let's say we make a new project here and we are dealing with several different files at the same time, and we want a common link between all these files. So extern will be a variable which will be used by all these files. It will be common to all of them, right? The value will be the same. Now the registers value again is a garbage value when it is initialized. On the other hand, extern is initialized with a value of 0, right? In the case of static as well, the variable is initialized with the value of 0, but what happens is that in static variable is never initialized again, right? So if you say we make I equal to 1, and again if we are trying to say I equal to 2, it is not possible. In case of static variables, we can only modify these values, right? We cannot initialize it again. So that is what static does, and static is mostly used in a program where we are dealing with different blocks to make a common point of contact between all the different functions, right? So we'll discuss about functions in a while in this series. So that is what static variables are used to do. Again, auto is all the default ones stored in the CPU's memory. Register is used to store it in the register's memory. Extern is used to link between several different files, and static is used to link between several different parts of the same program. Auto and register are initialized with garbage values, and extern and static are initialized with 0. Right. So these are the storage classes available in C, and that's all I have for you guys in this one. So thank you guys for watching. I'll see you guys in the next one. Welcome to the last video of this section. Now in this video we will be talking about something called as an enumerated data type. Now what an enumerated data type does is that it gives us the power of creating our very own data type, and we can define all the values that a variable of our own type can take. It is basically another way of declaring constants in C, and it helps a lot in making the program a whole lot easier to understand to the user. So let's say we are writing a code and we want to take the marital status of a person, right? So a person can be single, married, or divorced, either of the three, right? So what we can do is, instead of asking the user for 0 for single and 1 for married and 2 for divorced, it sounds very vague, right? So instead, it would be great if you could actually take the word single as the and store it, right? So let's try making that. The keyword for enumeration is enum, and we need to give it a name. Let's say marital status, and here inside the block we need to define all the possible values that it can take. So we have single, we have married, and we have divorced, right? So these are the three possible values which our variable can take, and it should end with a semicolon. And now, just like we declare int a, in a similar way we are going to declare a variable of our own type, which is marital status person 1 and person 2. Let's say we have two people, 2. So now when we take the input, we can simply ask the person to enter his marital status, and we can store it like person 1 is equal to single and person 2 is, let's say, divorced, right? So as you can see, this makes the program a whole lot easier to understand for the user, because in the menu, instead of saying 0 for single, he can actually enter single, right? So this is what the user sees. Now let me tell you what happens behind the scene. In the memory, all these three identifiers are represented as constants only. Single is treated as 0, married is treated as 1, and divorce is treated as 2 by default. You can give it any other value if you wish to, but by default it begins with 0 and incremented by 1 with all the variables, right? So whenever we refer to single, the compiler actually sees it as 0, but for the user's understanding sake, we are referring to it as single, right? So that's how enum comes in handy whenever we are trying to give a menu to the user. It makes it a whole lot easier to understand. And that's all about enum that you guys need to know. So thank you guys for watching. I'll see you guys in the next section. Okay, so welcome to section 2. Now in this section we'll be dealing with functions. So in this video I'll give you a quick introduction to functions, and we'll be looking into everything in detail in the subsequent videos. So what is a function? A function is basically a named part of a program which can be invoked from other parts of the program as and when required. Right? That is how we define a function theoretically. Now let me give you one simple example which will make it very clear as to what a function actually is. Suppose you are having a party at your place, right? So you have to do different tasks. You want someone to bring a cake for you, someone to bring the dinner for you, and some other people to decorate the place, right? So what we are basically doing is we are dividing the work into several different components, and that is where the concept of functions comes in handy. What we do is we make a certain block of the program and we assign it a particular task. Again, we make another block and we give it another task. So this particular block becomes one function, this particular block becomes another function, and like that. And we can call any particular function any given number of times in our program, right? So that is what a function basically is. It is used to divide our task into individual components, which basically makes it easier to handle the entire program, right? Because if you're just keep on writing the code serially, then it's of no use. Let's say we have to add two numbers, right? And our program is doing just that. So we need to add two numbers many times. So instead of writing a plus b and using the plus operator every time, what we can do is we can simply call a function or something like that, so that this function can be called any number of times as and when required, right? So we just need to define the addition operation once and we can reuse it any number of times. So function basically helps us in reusing the code and dividing the program into logically different tasks. So that is what a function actually is, and from the next tutorial we'll be starting to make our very own functions. So thank you guys for watching. I'll see you guys in the next one. Welcome back to the second video. Now as I said, in this one we'll be making our very own function. So let's get started. There are three basic requirements for making a function. The very first thing is something called as a function prototype, right? So what a prototype basically is, it tells the compiler that a function with this name is going to appear somewhere in the program. So the function prototype is defined outside the main function, right? So this is where we define the function prototype. Let's say we are making a function to add two numbers. So we'll simply say add, and that is all. So I'll tell you guys what this means in the next video. In this one I'll just tell you the three fundamentals of functions, right? So this is the function prototype. It basically tells the compiler that a function with the name add is defined somewhere in our program, right? The next thing which we do is we define the function, that is called as a function body. So the function body is mostly defined outside the main function and below the entire code. You can define it just below the prototype also if you want to, but the most common practice is to define it after the main body, right? So here we'll again go ahead and we'll say add. We'll make two numbers a and b, and we'll simply display their sum. So we'll say the sum is percentage %d and a plus b, right? So this becomes the function's body.
And the third thing is the function call. Now function call is basically the statement inside our main body when we call the function. Whenever we want to use it, we need to call the function using the function call. So let's say we have two integers here, I and j, and we need to add these two integers. Let's say I initialize the value of I to 10 and j to say 98 or whatever, and now I need to add these two numbers, right? So what I'll do is I'll simply call the function add. So what this basically means is that it will call the function add. So the control will transfer here to the add function, and it will execute these two statements for us, and then the control will transfer back to the line following add. And since there is nothing else and the main function closes after that, so the program will exit. Right. So this is how the flow of the function goes. The first one is the function prototype, which basically again tells the compiler that something like this is about to come. Next we have the function body, which we define mostly after the main function's body, and then we have something called as a function call, which is used to invoke the function as and when required. We can call this function any number of times. Let's say I read a value here using the scanf statement, and then I can call it here again, right? So there is no limit as to the number of times we want to call the function, and that is what makes the concept of function very useful. We can reuse this piece of code a many number of times. Now imagine this time there are only two lines, right? But let's say we have a huge function, something like calculating the roots of an equation or something. So reusing it every single time basically helps us reducing the number of lines of code as well, and the number of errors which we might encounter at a later stage, right? So those are the three essentials of functions. This was just a demo again, so we'll make a very own proper working function in the next videos. Thank you guys for watching. I'll see you guys in the next one. Welcome back to the third video. Now as I said, in this one we'll be making a proper working function. So let's say we have to add two numbers, and we'll be making a function for doing that. Now there are again three things which are essential while making a function. The very first thing is the function return type, which is this, the very first thing that we write in the function body or the prototype. And next thing is the function name, so I'll just name it add, and in these brackets we have to add arguments, right? Now an argument is basically the value which the function might need, all the different values that the function might require. So let's say we are going to add two integers here, so we'll need to give the function the two integers to add, right, without which it cannot function. So we'll write int a and int b. Now make sure that you write it two times, right? You cannot write int a comma b, that is not allowed. You have to write the data type every single time. So we have to write int a and int b just like that. Again, this is the function's return type. So void basically means that this function is self-sufficient and it will not return anything back to the main body. On the other hand, if we write int here, so this basically means that at the end of the function's operations, it is going to return an integer value to the main function or whichever function has called this one. So we'll need to store this value wherever we call it, right? So let's first do void, and then I'll tell you about int as well. And now here inside the body we'll simply add the two numbers. So we'll just say printf the sum is and a plus b. So this is what the function is going to do. It is going to add the two numbers which we give it, right? So let's now go ahead and make the prototype as well. Void add, and here we need to specify the number and types of arguments exactly, but the name is not necessary. So again we have two integer arguments here, so that is what we specified in the prototype as well. The prototype is also referred to as function declaration sometimes, and the body is also called as the function definition. And now we'll call the function. So let's say we have two integers, and I'll initialize I to 10 and j to say 17, and we'll call the function add with the values of I and j, right? I and j. So now what this should do is it should call the function here. The control will be transferred to the function. It will see the two values are integers, so it will take these two values and assign it to a and b respectively, and then it will calculate the sum of a and b and display it to us. And after that the program should exit because there is nothing else following this body, right? So let's go ahead and run this and see what we get. Okay, so we get the sum is 27, which is correct because I is 10 and j is 17. Now suppose we have two more numbers. Let's say we have k and l as well, and we need to add k again and l again. So let's say k is say 20 and l is 90. So we need not write everything again. We can simply call add with the values of k and l. So that is how easy it is to use a function, right? It reduces our efforts to a minimal. We need not write the entire code again. We'll just call it once more. So let's try that out as well. We should get 110. Right, so we get the sum is 27 and the sum is 110, and similarly you can go on calling this function any number of times you want. Right, so this was a function without any return type or with the void return type, which is not returning any value. Now let's try making a function which returns an integer value. So in this case what we are going to do is we'll simply call the function to add and return the value to us. We'll not be displaying the value. So we'll make a temporary variable here sum, and we'll write sum is equal to a plus b, and we'll write return sum. Now this statement is very important because if we say int or if we specify any other return type apart from void, we need to return that particular value. So since sum is an integer, so we are returning an integer value here. If we say float add, so we need to return a float variable here. So if you go ahead and run this now, you will get an error because the sum is an integer and it expects a floating return value. But since we are dealing with integer at the moment, let's go ahead and make an integer one. Again we need to modify it here. The return type should be the same as the function definition, and we haven't changed the argument, so that looks just fine. Again let's try adding two numbers. So let's read the numbers from the user this time. So we'll say enter two numbers and scanf %d I and j. Right, so we have stored two numbers from the user in the variables I and j, and now we need to calculate the sum. So we'll make another temporary variable here, because as I said, if we are returning a value we need to store it here. So we'll say temp is equal to add of I and j. Now what this statement will do is it will call the function add, give it the values of I and j, and since it is returning an integer, it will store this result in the temp variable, right? So that is what this statement is going to do, and to display the sum we just need to display the value of temp. So we'll say the sum is %d and temp. Right, so that is one way of doing it. Let's see how it runs, and then I'll show you the another way as well. So we need to enter two numbers, let's say 1 and 2, and the sum is 3. So it works just fine. Another way of doing this statement here is we need not store it explicitly. We can directly call the function in the printf statement only. So if we say I comma j, right here in the printf statement, it should call the function and should display the return variables value automatically. So let's run this and see if we get it or not. So two numbers 4 and 5, and we get the sum is 9, right? So this also works fine. If you want to display the result, then you can do this. If you want to use the particular value of sum again in the main body, then you need to store it in another variable like we did with the temp. So just to recap one last time, return type, name of the function, and arguments. Now arguments are also referred to as parameters, which are basically all the things that a function needs to work with, and this is the function's body. If you are giving a return type other than void, you need to return the variable of that particular type. If you are returning a variable, you need to store that variable in the main body, or you can display it directly in the printf statement. And in the case of the prototype, the return type, the name of the function, and the number and type of argument should be equal or should be similar to the function's definition, and you need not specify the names of the argument here. Even if you give a and b here, it's not a problem, but who will write those extra things, right? So that was all about the basics of functions. Go ahead, create your own function, and in the next video we'll be talking about functions in a bit more detail. So thank you guys for watching. I'll see you guys in the next one. Okay, so welcome back to the fourth video. In this video, we'll be talking about something called as a recursion, which is basically a function calling itself inside its own body. This might sound a bit weird, but when we try to code it, it will all make sense. Let's actually try to calculate the factorial of a given number. First, we'll do it without recursion, and then I'll tell you how recursion simplifies whatever we are trying to achieve. So let's calculate the factorial right now. Factorial is basically the number is multiplied with its number minus 1 till we reach 1. So let's say we have to calculate the factorial of 5. So the factorial of 5 will be 5 into 4 into 3 into 2 into 1. Right. So since we have to repeat the statements multiple times, we need a loop. So let's take a temporary variable for storing the factorial, and we'll take a loop variable, let's say I. So we'll start the loop with the given number, which is x, and we'll go on till the number is equal to 1 with decrementing 1 every time. And now we can simply multiply this value to f every single time, f into I, so that we get the desired output, right? So let's say we have 3 here, so we'll first start with I is equal to 3. So this will become 3 because 1 into 3 will be 3. The next time it will become 3 into 2, and the next time it will become 3 into 2 into 1, right? So that is, the loop will run properly as we want it to. Now let's return the value of f and try to print it in the main statement. So we'll say printf the factorial of say 5 is percentage d, and we'll call the function here directly. We'll say factorial of 5. Again, it is not necessary that you pass only variables here. You can even pass constant values to the arguments, not an issue. So let's run this code and see if we get the required output or not. The factorial of 5 should come out 120, which it does. You can check it out if you want to, but it is correct. Now let's try doing the same piece of code using recursion. So in this case, we'll not need a loop variable. We need another temporary for storing the factorial, obviously. And here, if x is equal to 1, we'll simply return 1 because the factorial of 1 is 1 and we can't help it. The next step is else. If it is not 1, we need to decrement it by 1, right? But since we are not using a loop here, we want to call the function again. So we'll say f is equal to x into factorial of x minus 1. Right, so let me explain what this statement will actually do. Suppose we have 3, so the f value is 1 initially, x will be 3, so this condition will fail, so it will come to the else part. Now here it will be 3 into factorial of 2. Now it will again go and call this function back again. It will try to calculate the factorial of 2, but since it is again not 1, it will again go to the else block. Now the value of f will become x is 2 now, so it will become 3 into 2 into factorial of 1, and similarly it will go on till we reach 1, right? Because when it reaches 1, the x equal to 1 will be satisfied and the function will return the value of 1. And after we have calculated it, we need to return the value of f. So that's what we'll do. And again, let's try doing that. So we should get the same output as the previous one. So there we go, we get the exact same output 120, which means that the code is working fine. So this statement uses the recursion concept because the function is being called in its own body, right? A function calling itself in its own body. Hope you get the definition now. So recursion is basically another way of repeating a given piece of code without a loop, right? We are not using any loops here. We are simply calling the function again and again until and unless we reach our deadline condition, right? So that is what the concept of recursion is. So go ahead, try it out, and I'll see you guys in the next one. Okay, so welcome back to another section. Now in this section we'll be talking about pointers and dynamic memory allocation. Pointers are basically variables which are used to store the memory addresses of another variables, right? And dynamic memory allocation is basically assigning memory during runtime. So let's start with pointers in this tutorial, and I'll tell you about dynamic memory in the next one. So as I said, pointers are variables, so they can also be of the different types: int, char, float, double, etc. But we mostly use integer pointers because we don't really require others so frequently. The syntax for a pointer is star followed by the name of the variable, right? So in star p basically means that p is going to be a pointer type of variable. Now you can't simply assign a normal value to a pointer variable because it needs addresses of another variables, right? So let's go ahead and make another integer, say I is equal to 10, and now what we'll do is we'll assign the address of I to p, right? So as you know, this is the ampersand, which is also referred to as the address of operator. So the address of I is assigned to p, right? So the value of p now holds the address of I. It will be more clear when we actually see what the output is. So we'll say the value of I is, and we'll display I here, and in the next line what we'll do is we'll simply print the value of p is value of p is percentage d, again since it is an integer, and we'll say p. Now p again is a pointer variable. Let's take this to the next line, and let's run this code and see what we get. This will make it absolutely clear as to what we are talking about here. So as you can see, the value of I is 10 here, but the value of P is this huge number. Now this number is the memory address where the value of I is stored, right? So that is what a pointer is used to do. It is used to find out the address of the variables. Now the only place where we actually use pointers is data structures, which has got nothing to do with this tutorial series, but since pointers is an advanced concept in C, I thought I might just tell you guys about it. So that is what the pointer actually is. It is used to store the address of another variables, and there is no limit. This is again a one dimensional pointer, you can call it. This is a 2D pointer, which means that this pointer needs to store the address of another pointer. So Q will basically store the address of another pointer, something like that, right? So if you go ahead and display the value of Q now, the value of Q is, we'll say Q, and let's see what is the output which we get. So as you can see, you get the exact same value. Now why is that? Because we did not assign the address of P to Q, we actually assigned only the value, right? So now let's remove the asterisk and now see what the output is. So there we go, the output changed, right? So that basically means that P and Q are stored in subsequent memory locations because there is a difference of only 4 bytes. But again, now Q is storing the address of P and P is storing the address of I. So Q is basically a two-dimensional pointer, if you want to refer it that way. And again, there is no limit to this, so you can go on and on with it. But again, as I said, pointers are used exclusively in case of data structures. So you need not worry about them for now. You know what a pointer is, and that's good enough, because people are very scared of pointers, to be honest. The programmers don't like pointers, and that is the reason that they have been removed in the recent languages like Java, etc. There is no concept of pointers in Java, but they do come in handy while using data structures. So if you go ahead and learn data structures in the near future, you might require pointers a lot. So that was all about pointers which you guys need to know. So thank you guys for watching. In the next video we will be talking about dynamic memory allocation. So I'll see you there. Okay, so welcome back to the second video of this tutorial. Now as I said, in this video we will be talking about dynamic memory allocation. Dynamic memory allocation basically refers to allocating the memory to any variable at runtime, which means that when our code is actually being executed, when our program is running, at that time also it is possible that we make a new variable. Because if we use a normal variable like int a, what happens is that the memory is allocated during the compile time itself, right? Now for dynamic memory allocation, again we need pointers. So we'll make a pointer variable a, and we need another header file called the malloc.h, which stands for memory allocation.h. We use two functions here. The first one is malloc, and the second function which we use is free function. So let's go ahead and use these functions now. So we basically say int star a is equal to malloc and size of int, right? So this is what we do for using the malloc function. The pointer variable or the pointer here is basically used to reserve a memory address, and the memory is then allocated at runtime. So this is the syntax of the malloc function. Again, free a will basically deallocate the memory when we are done with the variables usage in the program, right? So int star a is equal to malloc size of int, or you can even give a here, does not matter because a is an integer variable, so either of the two works just fine. So this statement reserves or allocates the memory of a when our program is actually running. So if we are making a program wherein we want to make a new variable depending on the user's choice, so we are not sure as to whether we should reserve the memory at the beginning itself or not, right? So in such cases, this dynamic memory allocation concept comes in handy. Again, if you go ahead and try to display the values of a and the address of a, everything will be normal. The only difference is that it will be allocated during the runtime itself. Right, so that is all about dynamic memory allocation that you guys need to know. So thank you guys for watching. I'll see you guys in the next one. Okay, so welcome back to the fourth section. Now in this section we'll be dealing with structures and unions. Both of these are used to group different data types together, but there is a slight difference between the two. In this one we'll be talking about structures, and in the next one we'll be taking a look at what union is, right? So again, as I said, structure is basically a way to group different data types into one single unit. So let's go ahead and make a structure right now. The keyword for structure is struct. As you can see, it got bolded here, and this is the name of the structure. So instead of writing structure, let me go ahead and write student so that it will be easier to understand. Now what we can do in here inside these braces is that we can write all the different attributes or all the different variables which represent the student. So I can say int roll number, I can say character name of 20, I can make an array, I can make an array of marks, right? So as you can see, we have different data types into one single unit. That is what a structure basically is, and it ends with a semicolon here. So now when we make a variable of this structure, it basically means that all these values should be initialized or should be declared for that particular variable, right? So this is basically another user defined data type, because we are telling the compiler as to what all do we require in a variable. So let's go ahead and make a variable. So we need to say struct student and the variable name, say s1. So as soon as we write this statement, what will happen is that the s1 memory space will be allocated and all these variables. Now as soon as we create this variable s1, what happens is that all these values are now as soon as we write this statement struct student s1, what happens is that all these variables are allocated memory, right? So for one single s1 we have these different variables in the memory, so we need not initialize it every single time, like roll number differently and character name again. So as we can, so if we say s1 s2 s3 etc., what happens is that there are three different students, right? So for s1 we have one set of values, for s2 we have another set of values, for s3 we have another set of values. So you see how easy it is to actually club different values together into a single unit, because that reduces our typing efforts. We'll need to write roll number s1, name s1, marks s1, and then again we need to write roll number s2 etc. So this is how you reduce the work. It actually initializes everything for all the three individual objects, all the three individual variables, right? These are called structured variables here. So let's actually go ahead and read a few values so that you understand how to use it. So I'll say enter details, and I'll go ahead and read them quickly. So let's say one name, percentage s, since it is a string, and we'll say name. No need of ampersand because we are dealing with strings. Then again printf 2, say roll number, we'll read only two values. percentage d, since it is an integer, ampersand, comma, ampersand, roll number. Now one thing that we need to take care of here is that we can't just write name or roll number, because which variable does this correspond to? Does this mean the name of S1? Does this mean the name of S2? Or is it or does it mean the name of S3? So we need to specify which variable we want, and we need to use a dot operator, right? So we'll say S1 dot name, which will make it clear to the compiler that we are dealing with the name of S1 variable, and again we can write S1 dot roll number. So let me quickly go ahead and print them as well, so that we can see if they are actually being read or not. I'll simply print percentage s percentage d name comma roll number. Again here we need to specify which name are we referring to. Right, so that should be enough. Let's run this and see what we get. Alright, so it asks me my name is Aquib, my roll number is this. Right, so we got the output Aquib 17, which is what we wanted. Right, so that is basically what a structure is. It is used to group different data types into a single unit, and you can also create variables here, right, like S1, S2, S3, etc. There is no specification as to you should define it only inside a main. The only thing is, if you are doing it inside main, you need to include these two things, and if you are doing it here, you need not mention them again, because that is in the same body. Right, so that is all about structures. One more thing is that you can also create an array of structure variables, right, like S10. Suppose you have 60 students in the class, so you can directly go ahead and write S60 here. Again, for reading the 60 values, you need to use a for loop, and you can do that very easily, right? So it is also possible to have arrays of structure variables. You can have as many variables here as you want, but you cannot have functions in here. That is the drawback of structures. It can contain only variables, right? So it is not possible to have functions inside here. Again, struct keyword, student is the name of the structure or the identifier, and in this block you need to specify all the different data types you want, and a semicolon at the end. So basically we are creating our own data type, right? It is a user defined data type. So when I create a variable of that particular structure, these three values are stored for me in the memory, right? I get memory allocated for these three variables. So if I am saying S60, as we are doing at the moment, it will allocate 60 different sets of these three values, right? So it will be S1 dot roll number, S1 dot name, S1 dot marks, one set, S2 dot roll number, S2 dot name, S2 dot marks, second set, so on until S dot 60, right? So that is what a structure is used for. So that's all about structures actually that you guys need to know. So thank you guys for watching. I'll see you guys in the next one, where we'll be discussing about union. Okay, so welcome back to the second one. Now, as I said, in this tutorial we'll be talking about something called as a union. It is exactly similar to structure in the way that we can also create, different data types into one single unit. The syntax is also the same. We use a union keyword, the name of the union, and we give all the different values that we want: int roll number, character name 20, and we said marks, right? So we'll go ahead and make that as well. So int marks, it also ends with the semicolon, and we can create a variable right here. So this is the this is an example of union, exactly similar to structure. Now what is the difference between the two? The difference is actually in the way that it handles the memory allocation for this data, right? So what happens in the case of structures is that we allocate 2 plus 20 plus 10, that is 27 bytes of memory for one single variable. But on the other hand, in the case of union, it only uses the highest value, so it will only require 20 bytes for all the three variables. Now how does it do that? It basically forces us or forbids us to use only one value at a time. All these three values share the exact same location, and that is why we are not able to access multiple values at the same time. We can access only one of these three at a given point of time, right? So you will understand better when we actually write a program. So we'll again read a value and we'll print that back. That will be enough for you to understand what I mean. So we'll take name as the input. Again we need to say u1.name, because if we have multiple objects it is confusing. And here let me specify what the user needs to enter. Right, we'll also read the roll number quickly. Ampersand u1 dot roll number. So now in the previous example what we did was we displayed both these values in a single line, right? We said percentage as percentage d, and we said u1 dot name comma u1 dot roll number. But that is not possible in the case of a union, because as I said you can access only one particular value at a time. And now let me show you something really interesting. Let's go ahead and try printing the name so that you'll understand exactly what I mean. Right, so my name is Aquib and roll number is this. Now as you can see we get something unwanted here, garbage value, and that is because we were referring to roll number currently, right? So until and unless we finish using roll number, or until and unless we go back to name, we read the name again or something, we cannot use name. So because the current value that it holds is the roll number, so we can actually display the roll number and see if we get it or not. So let's try that as well. So as you can see we get the 17 output perfectly, and that is because as I said we were referring to roll number the latest. That is because we were referring to roll number in the latest statement, right? So before this statement we were dealing with roll number, and that is why we can only deal with roll number until or unless we re-initialize the value of name or we reread the value of name. So if you want to display the name you need to do it right here before switching to another value, right? So that is the drawback of union, or you can say advantage in a way, because it uses less space for every variable than a structure does. So it is better at memory handling if you are sure that you need only one value at a given point of time, right? So again union keyword name, and in this braces you need to give the different variables that you want to. It will only take the maximum variables memory size, right? So since we have 20 as the maximum size here, it will only use 20 bytes of memory for the entire program. But the drawback is that we can only refer to one particular variable at a time. But if that's what you want, then this is how you do it, right? So thank you guys for watching. I'll see you guys in the next one. Alright, so welcome to section 5. Now in this section we'll be talking about file handling in C. What I mean by file handling is that we can actually create and modify files from within a C program itself. Right, so in the previous section we took a look at how to use structures, right? What we can do is we can actually store all the different values from the students that we took, right? We can actually make an entire database and we can store all those values taken from the user, and we can reuse it in our code whenever we want to by creating files. Now before actually beginning with the programming part, which we'll do from the next video, in this one we'll be taking a look at the different file modes available in C. There are three different modes and each comes in two divisions, right? So there are basically six different modes, but we'll be dealing with only three because the other three are very rarely used, right? So the very first mode is something called as read mode, the second one is the write mode, and third one is the append mode. Now in the read mode what you need to do is the file should exist, right? Because if the file does not exist you cannot read it and you cannot modify it. You can only read the contents of the file, right? In the write mode what happens is that if the file does not exist we can create a new one, and if the file already exists it erases the previous content and makes a new file, right? So that is what the write does. We can alter the file using the write mode. And the append mode is basically similar to write in the sense that it also creates a new file if it does not exist, but if the file already exists, what it does is that it appends the values to the end, or basically it adds the content to the end of the file. So if there is already a content in the file, it basically goes to the end of the file and there the rest of the content is stored. On the other hand, the write mode deletes all the previous content and then makes a new file, right? So these are the three modes which are very widely used in file handling in C. So that was all about. So make sure you remember what I just said, and I'll see you guys in the next one where we'll actually begin with the coding part. Okay, so welcome back to the second video. Now, as I said, from this video we'll be starting to write the code for creating and reading and writing and altering files. So there are two important things that we need to know before actually creating a file. The very first thing is that file handling concept uses pointers. So if you guys have skipped the pointers video, I recommend you go and watch it now before proceeding with this one. And the second important thing is that you need to remember the location wherever your .c file is saved, because that is where the file will be created, right? So if you don't remember your location, don't worry, you can see the location right here on top of the bar. So it says G chalksheet, and that is where my .c file is located. So you can also see your location there. So make sure you remember that location, because we need to open it while in the middle of this tutorial, right? So let's get started then. The very first thing we need to do is we need to make a pointer to connect to the file. So file star fp is basically a file type pointer. Fp is an identifier which basically represents file pointer, but you can give it any name you want. Fp sounds good to me, so I'll keep it that. And file basically is defined in stdio.h, so that is where it came from, if you guys are wondering. Now the next thing we need to do is we need to create the file. So we use the fopen function for that, and before actually creating a file we need to connect it to the pointer again. So we'll be referring to the file using the fp pointer. In the first double quotes we need to write the name of the file. I want to call it sample.txt, and in the second double quotes we need to mention the mode in which we want to open the file. So I want to open it in write mode. We use W for write mode, R for read mode, and A for append mode, right? Now from these two statements we have created a new file, but actually now what we'll do is we'll actually write some value in it so that we can check whether whatever we have done is correct or not. The file will be created only when we run our code, right? It is not possible to create a file without running the code, obviously. So since we haven't run our program yet, the file has not been created yet. But now let's actually try writing some value in it. So there are different functions used for writing values. The most commonly used is fputc, which is used for writing a single character in a file. We use fputs for writing a string value in a file. So let's actually go ahead and use fputc here. And characters are used in single quotes, right? So I'll say A. Let's keep it simple, and here we need to mention the pointer which we are referring to. So we'll say fp, which basically means that we need to write A in the file which is represented or referred to by the fp pointer, because it is possible to open multiple files at the same time. So we can have ft, we can have abc, whatever you want. We have n number of pointers here. We can use n number of files simultaneously. So this specifies what file are we working with. And now we need to close the file after we are done with everything. So we'll say fclose of fp. This will basically do two things. First, it will deconnect or dereference or delink the file from our code, and it will free the memory space used by the pointer fp. So it is essential that we always close the file, because that frees up the memory space. But if we run this code now, we will not be able to find out whether the file has been created or not unless we explicitly go to the folder and check it out, right? So there is a way of finding out whether the file creation was successful or not, and that is by using a comparison. So we'll say if fp is null, which basically means that if the pointer holds a null value, which basically means that it is not pointing to anywhere, so that means that the file has not been created. There was some error. So we'll say something went wrong. you cannot fix the error explicitly because that is the internal machine error, so it is not possible for us to fix by code. And if we hold some address, which means that the file has been created, we say everything looks great, right? So that is how you check whether the file creation was successful or not. Now what this piece of code should do is it should create a new file. So if you guys go ahead and open up the folder right now before running the code, you will find that there is no file with the name sample. But once we run this and then you open it up, you will find that the file has been created. So let's run this and see what we get. So there we go, everything looks great, which means the file creation was successful. Now before actually opening the folder, I want to tell you guys this. There is a very rare possibility that this creation will fail, because in today's laptops there is no memory constraints, right? We have unlimited memory for making a simple file, right? A txt file requires what, 2 KB of memory, maximum 1 KB, 1 to 2 KBs, right? So that is available easily. But what used to happen in earlier computers was that the memory was very restricted, there was not much memory available, and there people used to get these errors out of memory and stuff like that. So that is what we are trying to check here. But since our laptops are more advanced than the previous ones, so 99.9% of times the code will compile successfully and you will not get any error. So now let's actually open up the folder and see if the file has been created or not. Right, so there is my cpp. Right, so this is where my .c file is stored, as you can see, and there is a sample.txt document which we made in the program. So let's open it up and see what we have. So there we go, we have the a which we wrote in the code, right? So that is how you actually create a new text document without using notepad, right? By using C completely. So that is how file handling is used, that is how you create a file. And in the next video we'll be taking a look at how to open the file and how to modify the contents. We'll try using the fputtest function in the next video, right? So go ahead and make your own file, and thank you guys for watching. I'll see you guys in the next one. Okay, so welcome back to the third video. Now I hope you guys have learned how to create a new file. In this video we'll be taking a look at how to open that file and how to alter the contents. So again, make sure that the file is saved in the exact same location where you have the .c file stored. So as you can see, I have the file sample stored in the folder where I have my .c file. Now we'll be trying to open that file. So again, let's connect it to a pointer first. So we'll say fp is equal to fopen, and we'll be opening it in read mode for now. So file name is sample.txt. Make sure you do not misspell the name, because then it will throw an error saying that the file does not exist. Again, for checking whether the file opening was successful or not, we'll check the condition fp is equal to null. So we'll say the file doesn't exist if the pointer is null, which means that if it does not point anywhere. Else printf file opened successfully, right? So now we have opened the file successfully. It should open up because we have the sample.txt file in our folder ready for opening. And now I'll tell you how to read a value from the file. So first let's make a variable for storing the value. So since we have a character in the file, let's make a character variable, and we use the fgetC function for reading the character from the file, right? So for the syntax of the fgetC function is something like this. We write fgetC fp, which specifies which file's character we want to read, and we write the variable equal to. So c is equal to fgetC of fp will read the first character from the file and assign it to the c's value. So we can now display %c, and we can actually write the value read from the file is, this should be printf not scanf, so it's a printf, and %c, so we need to mention c here, comma c. There we go. This should display the value of the character read from the file, and after we have done everything we need to close the file, so we'll say f close fp. Now let's go ahead and see if we get the desired output or not. Since our file contains a, we should get an a as the output on the screen. So there we go, the file opened successfully and the value read from the file is a. So as you can see, we got exactly the output which we desired to. Now let's actually open the file again and we'll try to modify the content. So we'll put /n. Now since we don't need this piece of code, what we can do is we can actually comment it out so that the compiler ignores this piece of code. And now since we have a pointer assigned already, we'll simply go ahead and open the same file. We'll say open sample.txt for the append mode. Right now, as I told you in the first video, that append mode is used to add content to the end of the file. So let me just make it clear for you guys. Right, so there we go. This will basically add content to the end of the file. Now we'll try using the fputs function. So we'll say fputs my name is Aquib. Right, so let's see if this works or not. And again we need to mention the file pointer here to tell the compiler which file we are dealing with, and this should do it. We should close the file after everything. Right, so this statement, so this piece of code should basically write my name is Aquib on the file. So let's run this and see what we get. Again we have not checked for any conditions or anything, so we'll not get any output. But let's open up the file and see if there has been any changes in it or not. So as you can see, it has written my name is Aquib after a, which is the append mode, right? So see how cool is that, we are writing stuff in the file without even opening the file, right? So that is the power of C. Alright, so that is how you read a file and how you alter the contents in a file. Now if you want to remove the previous content, you just go ahead and replace the a with w. Run this again and I'll tell you the difference. So again, since we have not used anything, we will not get any output. And now when we open up the file, the a is removed, we get only my name is Aquib, because we opened the file in write mode, which as I told you erases all the previous content and starts writing new content from the file, right? So that is how you use the fputs function and how you read and alter the contents of a file. So that is all about file handling that you guys need to know. Go ahead, challenge your friends to make a file without using the notepad editor, because now you know how you do that. So thank you guys for watching. I'll see you guys in the last video. Alright, so welcome to the last video of the course. Now in this video we'll actually not be learning anything. I just wanted to thank you guys for taking this course, and I'm going to do that with the help of a simple C program. I'll simply print whatever I want to on the screen. So I'll say thank you so much. I'll go to the next line and I'll say this was fun. So there we go, my program says everything that I wanted to tell you guys. So let's run this and see for the sake of formality, because you know what the output is going to be. I'll simply say whatever I want you to. So thank you so much guys, this was fun, and if you have any doubts, any queries, you can always ping me in the discussion section. So once again, thank you all for taking the course. I hope to see you soon. This is me signing off.